Let's starting. In this session, we are going to discuss what are the concepts we are going to cover as part of Master Snowflake. Okay, let's start discussing what are the concepts we are going to discuss. First, we'll start with Snowflake fundamentals. Then we are going to discuss all these concepts with you. So first we'll start with what is Snowflake, and then we are going to understand what is data warehousing, what are traditional data warehousing technologies available compared to traditional data warehousing, what are advantages in Snowflake data warehousing, and then we are going to understand Snowflake architecture. What is Snowflake architecture? What are its advantages? There are three layers of Snowflake architecture. We are going to discuss all three layers, and then we are going to understand different editions of Snowflake. There are multiple versions of Snowflake. We are going to discuss all those versions. Once we complete these editions, we are going to see practical how to create free Snowflake account. Then how to sign in Snowflake, and we are going to understand Snowflake web user interface. There are multiple ways to connect with the Snowflake. We are going to see Snowflake web UI. Using Snowflake web UI, we are going to sign in and we are going to understand Snowflake web user interface. Once we connect this one, we are going to understand what are other different approaches available to connect to Snowflake data warehouse environment. Okay, once we understand the different ways of connecting, then we are going to set up a Snowflake development environment for creating a database, creating schema, creating tables, inserting data. We are going to see database setup. And then once we understand these concepts, we are going to see one important feature called SnowSQL. So this is my Snowflake cloud and my mission. Let's say this is my mission, Windows mission. In Windows mission, or this is my Linux mission, maybe Windows, maybe Linux. You can install command line tool called SnowSQL. 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 We can install command line tool called SnowSQL. Then we will create a connection between your Snowflake account with SnowSQL. Let's say I have data in my local file system. Yep, I have data in my local file system. I want to load it into Snowflake tables. Snowflake tables. So using SnowSQL, how can we load local file system data from your local file system to Snowflake tables? We are going to discuss complete SnowSQL installation and how to connect with the Snowflake environment. Then how can we copy local file system data to Snowflake environment? Okay. Then once we understand this one, along with this one, we are going to see some other clients to connect with the Snowflake. We are going to see DBever. There is a client, most popular RDBMS client called DBever. We are going to see connecting Snowflake cloud using DBever, then writing SQL queries. Okay. So once we complete this one, then here I'm moving these concepts to here. Then once we complete the Snowflake fundamentals, we come to know complete Snowflake environment and databases, schemas, Snowflake architecture, and then we are going to understand how to insert the data, and then we are going to discuss SQL for Snowflake. So this SQL for Snowflake, I mainly designed for who are directly joining Snowflake. They do not have any SQL knowledge. They are coming from different backgrounds. They are learning Snowflake. So this is very, very important for them. So we are going to understand what is SQL, what are SQL languages, and how to write DDL queries, what are DDLs, how to write DDL queries, then DML queries, DRL or DQL queries, transactional language queries, DCL queries, then filter commands, means while with different filter conditions. So this entire SQL for Snowflake. So once you complete this one, you will get a SQL knowledge and you will get a understanding of not only understanding with the practical of working with the Snowflake. Once this one is completed, we are going to discuss AWS fundamentals for Snowflake team. Why AWS fundamentals for Snowflake? Let's say this is my Snowflake cloud. Snowflake cloud. My data is presented, assume my data is presented input source data in AWS. In this AWS, data is presented in S3 service. S3 service. Then my requirement is I want to copy data from AWS S3 to Snowflake tables. Snowflake tables. For this one, we need one more additional service called AWS IAM. We need knowledge of AWS IAM. Without AWS IAM, we cannot access any other service in AWS cloud. So we are going to discuss what is AWS cloud and how to create account in AWS cloud. Then we are going to understand AWS cloud free tier, and then we are going to discuss one AWS EC2 service. EC2 service. Then in this EC2 service, we are going to see installing SnowSQL. SnowSQL. In this EC2 service, we are going to see Linux installation. And then before this, we are going to see In Windows, we are going to see SQL installation. Then we are going to see moving local file system data from Windows machine to Snowflake. Then once we complete EC2, we are going to see moving data from Linux to Snowflake. Both the environments we are going to see. Once this one is completed, then we are going to understand AWS S3. This is our main source. Maybe they are getting data from different approaches into S3. Once data is loaded into S3, we want to copy this data into Snowflake tables. For this one, first we need knowledge on S3. How S3 is going to work? What are different S3 concepts? If I want to read S3 data, what are I need from my Snowflake side? Then we are going to discuss complete practicals of S3. Then it uh, then we are going to understand AWS. I am also required to access S3 service. Then we are going to discuss AWS IAM service. These are very important for interacting AWS from our Snowflake. There are multiple approaches to connect from Snowflake to AWS. So all those approaches, first we need to have an idea. So first we are learning AWS or Snowflake. Once we complete this one, then we are going to start master Snowflake concepts. Master Snowflake concepts. Once we complete this Snowflake fundamentals, we are going to discuss SQL for Snowflake. Then once it is completed, we are going to discuss AWS fundamentals for Snowflake. Then we are going to start master Snowflake. Here we are going to discuss all advanced concepts. We are going to understand this part. Snowflake separates storage and processing. We are going to discuss processing part first. Processing part. This processing part. Then we are going to discuss this storage part. Storage part. And then once we complete this parts, then we are going to start advanced concepts like time travel, failsafe, types of tables, stages, internal, external, streaming using Snowflake, cloning operations, and views, procedures, user-defined functions, user management, resource monitoring, and lot of advanced concepts we are going to discuss. Once all these concepts are completed, we are going to discuss one end-to-end project using different Snowflake concepts. We are going to discuss loading data from different sources, and we are going to set up environments like raw layer, stage layer, and final target layer, and then what kind of operations we are going to do as part of Snowflake project. Okay, we are going to discuss all these concepts with practical examples too. And once we complete all the jobs, there is a concept called tasks in Snowflake to automate Snowflake Snowflake jobs. I may created multiple SQLs. I do not have any other. Then using different concept called Snowflake tasks, we can automate. Entire end-to-end with multiple scenarios we are going to discuss. So for entire this Snowflake, you need minimum knowledge of computers. And then SQL knowledge is required to become a Snowflake developer. That part we are covering here. If you are having SQL knowledge, it's more add-on advantage. If you do not have even single line of SQL, we are covering as part of our master Snowflake course. And then basic knowledge of any cloud. Here we are covering AWS cloud team. AWS cloud. Yeah, let's starting as part of master Snowflake. First, let's understand what is Snowflake. So first important one is Snowflake is a cloud data warehousing platform. Cloud data warehousing platform. What is the meaning of this cloud data warehousing platform? Let's take traditional data warehouse, traditional data warehouse, data warehouse. So traditional data warehouse, we can set up infrastructure. It may be on-prem or it may be cloud environment. So we are going to create multiple missions in a cluster. So multiple missions in a cluster. So in these missions, we are going to install traditional data warehousing services, data warehousing uh, software. But coming to Snowflake, Snowflake is a software. It uses cloud services in the backend. Cloud services in the backend. So here you no need to install anything. You no need to install Snowflake software. What you are going to do is you are going to create a account in Snowflake. You are going to create a account in Snowflake. Let's say this is my Snowflake, and as a user, I am going to I am going to create a account in Snowflake. While creating Snowflake account, we can choose a backend cloud. We can choose a backend cloud. It's currently supporting three cloud environments. It currently supporting three cloud environments. One is AWS, another one is Azure, another one is Azure, and next one is GCP. It is supporting three cloud environment. GCP, GCP. Okay. So if you use Snowflake, we need to create a account in Snowflake. While creating account, we are going to select a required cloud. Required cloud. Let's say I like AWS because I am using AWS from long back. Let's say I am Sreenivas, I am having organization. For my organization, I am using complete AWS environment. for multiple of my projects. So I'm interested with AWS. That's why I'm using Snowflake data warehouse. Backend for Snowflake data warehouse, I'm using AWS cloud. Your client, let's say your client X is using Azure cloud in their applications. So he want to use Snowflake backend is Azure. Next one, someone is XYZ bank using GCP for their complete banking application. They want to go with Snowflake backend with GCP. This is one factor. Second factor, second factor is cost. So there are two types of cost routing. Snowflake, Snowflake separates storage and processing separately. It separates storage and compute resources. Coming to traditional data warehousing, I said we create a we create a cluster. Let's say I created multiple missions in the cluster. In the cluster. So let's say this is master and these are workers. In this worker missions, storage and processing both are in a same mission in traditional architecture. But here Snowflake separates storage and compute resources. Let's say, let's say I created Snowflake account. I chosen background cloud for my Snowflake is AWS. Then then it uses AWS S3 for storage, AWS S3 for storage, and EC2 missions for processing. EC2 missions for processing. So storage is separate and processing is separate. Storage purpose, it is using different service. Processing purpose, it is using separate service. That's why we are saying Snowflake separates storage and compute resources. What is the advantage of this one? So it is getting benefits of underlying cloud. So AWS S3 supporting unlimited, not only AWS S3, every cloud file system is supporting unlimited storages. First important one, unlimited storages. These cloud file system do not have limitations in storages, whereas traditional data warehouse having a limitations in number of machines in a cluster. Traditional data warehouses having a limitations in number of machines in a cluster. So they have a limitation in storage. It varied from data warehouse to data warehouse. But coming to Snowflake data warehouse, we do not have a storage issue because it is using underlying cloud cloud storage service. If it is AWS, it is using S3. S3 uh, do not have a limitation in storage. Second one, processing. Processing, processing. Here we can create any number of instances. There is no limitation for creating instances. So here I said in traditional architecture, there is a limitation in number of missions in a cluster. So we have a limitations in processing. And that too, data not processed in distributed manner because storage and processing happens in same mission. But here, storage is different to service and processing is different service. Okay, let me elaborate here. So first important point, Snowflake is a data warehouse. Snowflake is a modern data warehouse. It separates storage and processing. Processing is a terminology. Generic terminology. In Snowflake, we use virtual warehouses. Virtual warehouse. The advantage of this separation is you can create multiple virtual warehouses. Let's say virtual warehouse 1 with 2 resources, virtual warehouse 2 with 4 resources, virtual warehouse 3 with 8 resources, virtual warehouse 4 with 16 resources, virtual warehouse 5 with 32 resources. Assume I created 5 virtual warehouses. Here I am getting SQL query. I am getting SQL query. This query, in this query, user written select statement with multiple filter conditions, with conditions, with multiple, with multiple conditions. Okay, multiple conditions, multiple conditions on 1 GB data, 1 GB data. So to process 1 GB data, this one is more than enough. We can use these resources, we can assign this virtual warehouse to process the data. And another SQL query he requested to process this SQL query, it required, this SQL query is going to process 10 GB data. Assume 10 GB data. So for processing this 10 GB data, two resources gets heavy. So we can choose this virtual warehouse. We can choose this virtual warehouse. So depends upon your data size, you can select a right virtual warehouse. Right virtual warehouse to improve processing speed. To improve processing speed. This is the main advantage of virtual warehouse concept today. One more important point. You may thinking, if I create multiple warehouses with different resources, is Snowflake going to charge price for each virtual warehouse? No. Whenever you selected, whenever you selected to process particular SQL query, let's say you selected this resource, virtual warehouse with 32 resources, and this one taken 1 minute time. So they are going to charge only for 32 resources in 1 minute only, based on time and how many resources are utilized. Based on that only, Snowflake is going to calculate pricing. It will not calculate for ideal virtual warehouses. This we created, just we created. These are not utilized. When resources utilized, then only Snowflake is going to generate billing. Yeah. Let's understand Snowflake cloud architecture. Snowflake is a cloud data warehouse software, cloud data warehouse software. While creating account, we can ask Snowflake to select a backend cloud. Currently, Snowflake is supporting 3 cloud environments. three cloud environments. First factor, first factor, first factor of selecting cloud. I am using, I am using AWS, AWS for multiple, for multiple of my projects. Then that's why I am showing interest to take Snowflake backend cloud is AWS. Second factor, second factor, pricing. Pricing of pricing of storage, pricing of storage, and pricing of processing. Processing. Let's say here AWS it uses S3 service for storage and processing purpose it uses EC2 and storage purpose it uses blob service of AWS Azure cloud. Processing purpose it uses virtual machines service. Coming to GCP, storage purpose it uses Google Cloud Storage and processing purpose it uses Google Cloud Engine Service. Little bit varied of storage, little bit varied of processing service of cloud to cloud. So this is also one factor client goes to select a cloud. Most of the time, client chooses first scenario. Most of the time, client chooses first scenario, and rare cases, people also gives priority to second also, because pricing also important. For us, it may be in a sense, dot sense, but when it comes to processing huge volumes of data sets, right? When it comes to storing huge volumes of data, it become huge amounts. So pricing also very important factor to select a cloud, backend cloud for your Snowflake team. And next, let's understand one more important point. Snowflake backend, if you select AWS, it uses AWS S3 for storage. It uses EC2 machines for virtual warehouse. If you select Snowflake backend is Azure, it uses Azure Blob for storage purpose. It uses Azure VM service for processing purpose. And if you select GCP as a backend cloud, it uses GCP Cloud Storage for storage service, and it uses Google Cloud Engine for processing. Okay, to learn Snowflake, we need basic computer knowledge. And second one, SQL is mandatory. Yes, why SQL is mandatory is Snowflake is a data warehouse. Data warehouse. Here, we are going to store the data in a tabular format, like RDBMS, like RDBMS. We are going to store the data in a tabular format. Tabular format means rows and columns format. So to deal with this rows and columns data, the common language is SQL. Common language for interacting tabular data is either it may be RDBMS, it may be RDBMS, it may be data warehousing systems. Common languages, common languages, SQL language, SQL language. So we are going to, sorry, SQL is a prerequisite for Snowflake data warehouse. As part of our Snowflake course, Master Snowflake course, we are going to discuss this SQL also. As part of our course, we are going to discuss SQL. And next one, any cloud knowledge is required. Any cloud knowledge. Like, let's say, assume AWS having 200 plus services. 200 plus services. We do not require these 200 services knowledge. We require, first importantly, we require storage service. Storage service knowledge. Example, S3. Let's say in AWS S3, data is coming. Data is coming. And we want to move this data to our Snowflake data warehouse environment. So our requirement is we want to ingest data from S3 location to ingest data into Snowflake environment. This ingestion we can do in multiple ways. Multiple ways. So one, using Snowflake techniques. Snowflake techniques. So as part of our Snowflake course, we are going to focus on this Snowflake techniques to copy data from AWS S3 environment to Snowflake data storage. Let's say, let's say Snowflake storage in the tabular format. Here you may getting question. Let me first clarify your before asking a question. Let me clarify. Uh, Already I said our Snowflake backend storage. Let's say if I use AWS, already it is a S3. Then why we need to move again S3 data to Snowflake? Let me give a clear clarity so that you will get a clear understanding. So my client is X Bank. X Bank. X Bank, they are having project project one. So using this project one, they are collecting lot of customer details and all. Then where they are writing this data is, let's say, AWS S3. AWS S3, they are writing into RDBMS, they are writing into multiple locations. Let's say project one data, they are writing into S3 location. This is X bank related data lake environment. Data lake environment. So their requirement is they want to move this data into Snowflake. So we created Snowflake. We created Snowflake account for X bank. X bank, we created Snowflake account. While creating Snowflake account, we chosen AWS. We chosen AWS. And Snowflake people having their own account, they are going to give separate S3 storage for X bank. This S3 is X bank related storage service. But here, Snowflake is allocating a separate S3 storage for you. And it allocates a separate EC2 service for you based on your virtual warehouse sizes creation. VM1 to VMN. VMN. Now, now you want to move this data into Snowflake. It means here you are going to use Snowflake techniques. You are going to use Snowflake techniques to move this data into Snowflake table. Then using different reporting tools, you are going to connect with Snowflake and you are going to prepare a reports or dashboards. Clear writing? Yeah. Now let's start understanding what is a data warehouse. As part of Master Snowflake, let's start understanding what is a data warehouse. Yeah, let's start understanding uh, what is a data warehouse. First important point, a data warehouse is a centralized repository or place where we store history of data or huge volumes of data for analysis purpose. Let me add some points here before deep dive, before clear understanding of data warehouse. There are two concepts in OLTP and OLAP. OLAP. OLTP stands for online transaction, online transaction processing. Example, take RDBMS, take RDBMS, maybe MySQL, maybe Oracle, maybe other database. Let's say we have business application. Example, e-commerce application. Let's take e-commerce application. In this, multiple people interacting, like log into uh, e-commerce web page, searching the items, adding to cart, removing from cart, purchasing items, and raising feedbacks, writing comments. Lot of activities they are going to do. So for all these activities, they are going to perform CRUD operations. Create means create, read, update, and uh, delete operations. So reading the data, writing the data, updating the data, deleting the data, these kind of activities, we call it as online transaction processing. So live data, we can say. Coming to OLTP, so let's say these kind of systems, multiple systems, we have multiple sources. End of the day, management, management, they are not technical people. For them, we want to show reports either in bar charts, pie charts, some other format. We have to show reports to them. Let's say city-wise sales or product-wise sales. We want to show to management in the form of reports. So management sees these reports. So what we are going to do? We are going to take one centralized repository called data warehouse, data warehouse. So we collect data from different sources. We collect data from different store sources. Then we store the data. So we are calling history of data or huge volumes of data. So we are storing this data using different analytical softwares. Mm, They will connect this history store, then they are going to generate reports. So to perform operations on this history of data is not that much easy. That's why we are using ETL tools. In our case, let's say transformation tool, DBT, DBT. So whatever these people expecting, same format, we apply transformations on this history data. Results we are going to store it into target tables. These target table, these analytic people going to use. Instead of hitting this entire history of data, these people going to connect the target tables, these target tables input for analytical people. So understand him, OLAP means online analytical process. This is not live data. This data may be 1 day data or 1 week data, 1 month data, quarterly data, half yearly data, yearly data, 2 years data, 5 years data. It depends upon the business, how they are presenting reports. So based on them, we are going to store history of data into data warehouses. So data warehouse is a central repository from different sources, from different sources, uh, using different technologies. They store the data into data warehouse. Different data analytical people, not only data analytical people, like machine learning people, artificial intelligence people, our data warehouse become input to them, input to them. Okay. So data warehouse holds huge volumes of data sets or history of the data. On that data, what happens? Analysis happens. That's why we are calling online analytical process. So data warehouses comes under online OLAP systems. RDBMS comes under OLTP systems. Their live data is going, uh, inserts happening, updates happening, deletions happening, data creation happening. Lot of things live happening in that systems. So we have two categories. Our data warehouse comes under OLAP. In this OLAP, sorry, in this data warehousing, mainly we have these components. First one, ETL process. This is my data warehouse. Warehouse. This is my data warehouse. Let's say Snowflake. First important concept is ETL process. So source. Source may be file system. Source may be RDBMS. Source may be cloud file system. ETL. ET extraction, transformation, and loading. Loading. So they you connect sources, they perform transformations, then transformed results, they're going to load it into our data warehouse. Here, people uses different concepts like Python, PySpark, AWS data engineering services like Glue, Azure data engineering services, GCP data engineering services, multiple concepts industry uses like Informatica. Multiple tools are present and they connect to different sources. Then they load data into data warehousing. Another one, storage. This is our central store. Here we are going to store huge volumes of data. Next one, access layer. Once data is stored, we want to analysis on this data. Then access layer. There are multiple interfaces available to connect with data warehouses. Example, any retail company uses data warehouse for storing their history of data. End of the day, they want to do analysis. Let's say future in nearby a festival is coming, Christmas festival. They want to perform analysis on the uh, data or items or products in their retail stores, region wise, last 10 years data. They will apply machine learning algorithms. They will do analysis on product wise. Let's say in Hyderabad, what products are selling more? In Hyderabad, in Miapur area, which products are selling more? Such kind of analysis they are going to do on this history data, and so that they will get a clear clarity what kind of items in particular area people preferring, so that this retail company owners maintaining sufficient stock to improve their sales. Such kind of analysis they are going to perform on this central data or history of data. Yeah. Now let's understand what are limitations of existing or traditional data warehousing systems. Traditional data warehousing systems. First limitation is scalability. If we take HP Vertica, Teradata, Vertica, Teradata, and multiple top data warehousing systems, they have a limitation in cluster size. They have a limitations in cluster size. So because of that, you cannot store more than that cluster data. You can create multiple clusters, but even though that multiple clusters having also a limitation. So scalability is the main limitation in traditional data warehousings. So to avoid those problems, nowadays cloud data warehousing systems were invented. Because of that, our Snowflake, I said, it separates storage separately, processing separately. Storages, it is using cloud storage system. That's why cloud data warehousing systems, cloud storages do not have a limitations. It means our Snowflake do not have a limitation. Second one, cost. Let's say I am expecting lots of huge volumes of data. I developed a e-commerce project and I am expecting lots of data. That's why I set up a huge cluster for my data warehouse. I purchased hardware, I purchased a lot of things, I recruited many people. But initially, up to 1 year, my business is not grown. Very less data I have. But still, you have to pay money to hardware, softwares for licensing. You have to pay salaries to employees. Lot of limitations too. Performance wise also we have a limitation. Let's say you have one file with 10 GB data. That 10 GB data is stored in a single machine. So whenever you apply SQL query, single machine is responsible to process that 10 GB data. There is no distributed and parallel processing. So uh, performance wise also, traditional data warehousing having a limitation, and maintenance cost is high. You have to recruit multiple people for different operations like administration purpose and networking purpose, operating system purpose, and other administrators. Maintenance is too high, and other problems are flexibility thing. If you are if you are adding new features, you have to put your uh, data warehouse in maintenance mode. In maintenance mode, you cannot do any other operations. So until you upgrade, if there is anything happens in your upgrade, you have to resolve. Until that resolution time, you cannot do anything. Lot of limitations available in traditional data warehousing technologies. So first, our Snowflake resolves all these limitations. It supports all these kind of components, and it resolves all these limitations. So mainly data warehousing purpose to store history of data, and data warehousing's main purpose is OLAP, online analytical purpose or process. On this analysis happens, so our data warehousing data become input to data analytics, machine learning, and artificial intelligence. Our downstreams are data analysis people, machine learning people, and artificial intelligence people. Yeah. Now let's understand what is Snowflake data warehouse. Snowflake is a Snowflake is a cloud data warehouse. Currently, it is supporting three clouds: AWS, Azure, Azure, and GCP. While creating Snowflake account, while creating Snowflake account, we choose a backend cloud. We choose a backend cloud. And next one, Snowflake. Snowflake separates storage and processing. Storage and processing. Next one. Next one. There is no limitation for storage. There is no limitation for storage. There is no limitation for number of missions in processing. There is no limitation for number of missions in processing. Let me add point here. I started e-commerce business I started e-commerce business. Let's say I have only GBs of data in first 6 months. In 6 months, my expectation is I'm going to get huge volumes of data, but in 6 months, I'm doing lot of advertisements to to make my e-commerce application uh, reachable to many clients in all over world. Then initially it reached only few people. Few people started using this application. It generated max of GBs of data. I stored this data into Snowflake. Then let's say I can pay only for this GBs of data. In traditional architecture, whether your data size any, no matter how many missions you set up in cluster, you have to purchase hardware, you have to purchase licensing of softwares. Okay, for setting environment, you have to take data centers. Lot of things you have to invest. But here, for this storage, how much you used, you can pay only for that. So maintenance cost is less. Next one. To process this GBs of data, I need two missions one. I need four missions one. We have a virtual warehouse concept. Virtual warehouse concept. I can create a virtual warehouse one with two missions. I can create another virtual warehouse with four missions. Then these are more than enough. I am using few resources to process this data. Whenever my report required, then it will send request, right? It uses either two missions virtual warehouse or four missions virtual warehouse when we want to display a report. So processing also we are paying less amounts. Next one. All of sudden my application reached to many people in the world. Data is growing. Data is growing not like anything. Then you least bother about resources in storage, resource in processing. You just this storage automatically scalable. There is no limitation in backend of my Snowflake storage. There is no limitation. You can store any sizes of data. My data is growing. I need more missions. You can create different virtual missions with different sizes. Whatever the resource size you required, you can call only that virtual warehouse. Snowflake charges only for that resources. Even though if you create multiple warehouses with different sizes, they will not charge unless you use. So scalability is flexible. There is no limitation in storage. There is no cluster limitation like traditional architecture. There is no limitations of resources in cluster. You can create any number of resources in processing. Our storage supporting unlimited storage. And second one, like a traditional architecture, you do not require multiple administrators. If it is traditional data warehouse, along with the data warehouse admin, you need network administrator, you need operating system administrator, you need other administrators like power and other data center maintenance engineers, etc. But here, you no need to do anything. Zero management cost. Okay. There are plenty of features or advantages in Snowflake. That's why most of the people migrating their traditional data warehousing into Snowflake data warehousing. Clear writing? What is Snowflake? Yeah, let's start in. As part of Master Snowflake, in this session, we are going to discuss Snowflake data warehouse architecture. Snowflake data warehouse architecture. Yeah, Snowflake follows three layer, three layered architecture. Three layered architecture. Okay, order may be anything. So cloud services. Second one, query processing. And third one, database storage. Database storage. Okay. So Snowflake, as we discussed, it separates storage and it separates processing. So this is three layered architecture: cloud services, query processing, and database storage. Yeah. Now let's understand database storage. So this is actual storage of your Snowflake data warehouse. So you can, this database storage can store any size of data. There is no limit. It supports unlimited storages. In this storage, in this storage, it currently supporting three cloud file systems. It is supporting AWS S3, AWS S3, Azure Blob, Azure Blob, and next one, Google, Google Cloud Storage. So currently, this storage, it is supporting three clouds. While creating Snowflake account, while creating Snowflake account, we choose backend cloud. If if we choose AWS, storage is S3. So we send, let's say, create table request. Let's say if you use create table command, what happens in AWS S3? It will create a folder under bucket. Under bucket, it will create a folder with your with your table name. With your table name. Under storage, it will create a folder with the table name. Here, here folder is going to create for your table. And in this metadata, it stores this schema details. Whatever table creation logic we write, right? That the table creation logic schema details are stored in this cloud service layer in Snowflake. Next one. If you write insert, if you write insert query to Snowflake, then under this folder, it is going to create a file with all your insert data. With your insert data, under this folder, it will create a file. Again, you write one more insert query for same table. It will create another folder, another file in this location. Okay. Next one. If I write select query, if I write select query to process this table, then here processing means virtual warehouse. Virtual warehouse. Processing is generic terminology. Virtual warehouse is a concept of processing unit in Snowflake. This virtual warehouse reads this folder and connects this uh, cloud service, understand the format of this data, then reads this data type. So query processing layer. If you use AWS, it is a AWS EC2 EC2 service. EC2 service. If you choose backend cloud is Azure. If it is Azure, it is a Azure VM service. If you choose GCP, it is a Google Cloud Engine. Google Cloud Engine. So based on your backend cloud, service is different. Let's say I choose an AWS for my Snowflake. Then storage is AWS S3 and processing is AWS EC2. So your select query is going to process by AWS EC2 machine. Clear writing? So here we understand AWS S3 is or any cloud file system supports unlimited storage. Yeah, sorry. Yeah. So here one important point is virtual warehouses we can create with different sizes. Two missions or four missions or eight missions or 62 missions, 32, 64, 64, etc. etc. While sending these requests, while sending these SQL requests to Snowflake, we can select a write virtual warehouse to process your data. You can select a write virtual warehouse to process the data. So clear writing, data storage and virtual warehouse. Data storage, database storage supports unlimited storages. It uses cloud storage service. If it is AWS, it uses S3. Query processing is responsible to process your queries. Process your queries on the data. Here, if it is AWS, it uses EC2 machine to process this data. And very important one is this layer. We are not going to do with this layer. Actual Snowflake software contain this entire layer. Here, first one, authentication, authorization, and access control, like creating users, giving access permissions. granting, revoking, etc. And here, these resources we can create with multiple sizes, and this storage information complete managed by infrastructure manager. If you submit any query to Snowflake, that Snowflake query before handover to EC2 mission, it perform optimization techniques, then handovers. And metadata manager is responsible for these kind of meta information. Metadata information is very important to access the data in storage layer. And next, security. Security. To access tables, to access the data, to give a privileges, everything under control of different components in cloud service layer. So these are three important layers of Snowflake. These are three important layers of Snowflake team. Snowflake data warehouse architecture. Is it clear? You have any questions team in this Snowflake data warehouse architecture? Yep. Let's continue team. So in this session, we are going to understand Snowflake editions. There are four Snowflake editions team. We have standard edition and enterprise edition and business critical edition and virtual private Snowflake VPS virtual private Snowflake. First important one is standard edition. Standard edition having a less features, but it is best suitable for small and medium-sized businesses. They need a data warehouse where they want to store huge volumes of data. So this standard edition gets core computing and storage, basic security, time, time travel only 1 day. Here, time travel means if you delete any table or any Snowflake object, so it will delete from Snowflake. If you want to recover or restore deleted Snowflake object back, there is concept called time travel. Using time travel concept, we can revoke deleted data. So that time travel only available only 1 day for standard, and remaining is standard data loading and standard data querying. So that's why it is best suitable for small and medium businesses team. And next very important one is enterprise edition. So enterprise edition best suitable for all organizations, small, medium, and large. It contains all advanced features, including data sharing. Let's say you have a one Snowflake cluster and you want to share your data to another Snowflake cluster. So that feature is available in Enterprise Edition. Along with this one, it provides a lot of additional security features. So this is suitable for all types of organizations. And along with that one, it provides time travel 90 days, up to 90 days. And along with this one, it provides fail-safe concept, and with the fail-safe concept, it provides additional days. And along with this one, automatic cluster and materialized feature, materialized views, and secure data sharing and multi-cluster warehouses. Multi-cluster warehouses. So these are uh, additional features compared to standard edition. Let's say you are storing healthcare data or you need more security or more encrypted data. Then another version is business critical edition. If you see here, business critical, you can see HIPA, HIPAA and PCI and uh, compliance features. Try secret secure encryption key management. Okay. And dedicated metadata services and high performance options. Let's say you have uh, finance, healthcare, uh, enterprises with strict and security requirements. Then this is best suitable. You are using Snowflake for banking sector or healthcare sector, and it is recommended. It is recommended. Other than this, if you are going for other organizations, recommended is enterprise one. Pricing is different to standard enterprise and business. Let's say your requirement is your requirement is a complete financial organization or healthcare organization. You do not want you do not want common or public shareable resources. Within the Snowflake, they have complete Snowflake environment, cloud environment. From that, they are going to give right resources. In, instead, they want client want dedicated resources. Example, let's say in USA, Snowflake. Let's say Snowflake, you are creating account. While creating account, you are choosing AWS cloud. In that, you are choosing, let's say, US region. Under US region, you are selecting X region. Let's say I am selecting X region. In this X region, I want these data center and these resources. Those resources should not be shareable to anyone. If you ask Snowflake to allocate such kind of resources, they have a separate plan called virtual private Snowflake. Virtual private Snowflake. Within this environment, no one going to connect. They are going to separate create a virtual environment network for you, but it is costly compared to all these three other editions. It is completely isolated from Snowflake public network. It is dedicated only for your organization. Example, uh, example, your client is banking client and they are storing sensitive data for data analysis purpose. They do not want to expose the data to any other people. They need a full security. Then, then they can ask Snowflake people to provide a isolated environment for them. So that's why while creating Snowflake account, you cannot see these virtual private Snowflake. If you want virtual private Snowflake, you need to connect with Snowflake people. So it contain custom network, it contain custom encryption controls, okay, highest security and dedicated cloud infrastructure. Okay, yeah. Let's continue. In this session, we are going to discuss how to create free Snowflake account and how to sign in Snowflake. We have different ways to sign in Snowflake. And then we are going to understand Snowflake Web UI. Okay. So first, let's understand creating a Snowflake free account, then sign into Snowflake account. And later, we are going to see overview of Snowflake Web UI. So first, let's open any web browser. I am opening Google Chrome. Here, enter this URL www.snowflake.com. Here you can see start for free. Click on this start for free. Here you need to enter your details. Remember team, here you can see no need of any credit card required. Backend we are using cloud. That cloud account is not yours. Snowflake Snowflake has their own cloud account. In that they are giving access on storage and processing layer for you. Okay. So $400 worth they are giving free. You can use that $400 within 30 days, or if 30 days reaches first, then your account will expire either 30 days or $400. Which one comes first? Based on that, your account going to expire. And here you can see fill this form team, enter your details. I'm entering my details. I'm entering Akkem Sreenivas. Then work email, I'm entering Akkem Sreenivas at gmail.com. Let me add one point here. If you are coming from cloud background, you may have a question. If we use one email for creating cloud account, once free tier is completed, we have to use another email ID and we have to create new account in AWS cloud. Yes or no? But here in Snowflake, you can reuse once 30 days are completed or $400 usage is completed. Then you can recreate with the same email ID. You can get all these above benefits. No need of a separate email for Snowflake. Okay, next one. I am signing this one for my uh, personal learning and development purpose. Yeah, now let's click on continue. Then here it is asking company name. Company name is not mandatory. You can give anything. I'm giving Akkem Sreenivasa. Then job title, I'm giving data engineering, data engineer. And here you can see Snowflake editions. Snowflake having multiple editions, standard edition, enterprise edition, business critical, and virtual cloud Snowflake. So total four editions of Snowflake is available. And you can choose any of these three. But virtual private Snowflake is not free. If you want your own Snowflake environment, you do not want publicly shareable locations. You want a separate data center and separate network, everything you want. You can connect with the Snowflake people. They create a separate environment for you. But cost is little higher than these three. We are going to discuss different versions and what are features in each edition. But in this, understand important one. If you use enterprise business critical, you will get 90-day time travel concept. Time travel is an important feature. If you delete any data accidentally, you can recover that data using time travel concept. In standard, you cannot get that benefit, but enterprise business critical, you can get it. So you can choose any of these three. All three editions comes into free edition, free trial. Yeah. Now, now I'm selecting enterprise. Then once you select edition, it is showing three clouds. You can choose any cloud. Here, important point to think. Storage is S3 and processing is EC2. Storage is blob, and processing is VM service. Storage is Google Cloud Storage and processing is Google Cloud Engine, Google Cloud Engine service. You may have a question, on what basis we may choose this backend cloud? I am giving two reasons, Tim. Two reasons. We may have multiple. These two reasons are very, very important. First one, everyone chooses based on cost. Compared to 1 minute. There is a separate topic in our Snowflake master Snowflake training. There we are going to discuss clearly storage, how cloud people calculates for your Snowflake account. Processing, how Snowflake people calculates. And second one, cloud to cloud. These service prices are differ. At least little pricing may be varied cloud to cloud vendor. So most of the people, for us, maybe it's a points or cents, but when it comes to business, right, it uses lot of resources, right? Even though we may see points, but when it calculates monthly, then billing cost may be differing uh, price wise. That may be one reason people chooses. Second one, second one. So I am Akkem Sreenivas. I am having e-commerce product, e-commerce product last 10 years, last 10 years onwards. I am using AWS cloud for many of my projects of e-commerce, many of projects of my e-commerce. I am very much satisfied with AWS cloud. I am very much satisfied with the cloud. This may be one more reason, even though cost cost compared to other clouds, cost is little higher. Even though AWS cloud cost little higher, but I am very much happy for my e-commerce project. I have 10 to 20 projects. All the 20 projects I deployed into AWS, I'm running happily uh, in AWS infrastructure. So I'm liking AWS. That one more reason people may go to cloud. You may be liking Microsoft. Someone may be liking GCP. So that is one more reason they may choose. Okay, let me choose a cloud. I am choosing AWS cloud. Then choose a reason. Choose a reason. I am choosing region. My nearest region is Singapore, Asia Pacific. Then click on uh, accept I read agreement. Then click on get started. Sometimes you may get this one. So it is asking uh, images, find images of bridges, 1, 2, and 3. Is it bridge? Aligned it? Select, verify. No. Crosswalks. Yeah. So next one, here, what you will see, what will you use Snowflake for? I'm using Snowflake for multiple purposes. This is optional. You can click on skip also. I'm choosing all this. and then you can click on continue. Select a preferred language to work with uh, Snowflake. I am choosing SQL, Python is my preferred languages. If you are a Java developer, you can choose. Even you can choose I do not have coding experience, or you can click on skip. Click on submit. Once you submit, once you submit, you will get a link to email ID. There you need to fill some more details. Open your email ID. See, we got an account. Then click on this link and fill the details. I am entering user details are Akkem Sreenivas. Then enter password. Okay. Then click on sign in. See here. Not this one. Click on click activate. Sorry. Click activate. Enter username Akkem Sreenivas. Then enter password. Then confirm password. Then click on get started. So your account is created. Your account is created. Then it is logged in automatically. Okay. So once account is activated, then I want to sign into Snowflake account. Snowflake account. So first one team. So first one, you will get a dedicated login URL. Let me sign out to this one. Sign out. Okay. Go to your account. So you will get a dedicated URL. Then open this URL. Enter your username. My username is Akkem Sreenivas and password is okay. Then click on sign in. Then it will sign into Snowflake Web UI. This one is Snowflake Web UI. Now let's sign out once again. Second approach. Second approach. Before that, once again, sign in here. Enter username. Then okay. First way. Second approach. Second approach. There is a separate URL app.snowflake.com. Let's take this URL. Let's use this URL in incognito window. Okay, let's enter here. App.snowflake.com. Here it will ask account identifier. How to find account identifier? Once you log in with your dedicated URL, you can click on this your user. You can see this one AAD63471. Then here you can see this is 67471. Click on view account details. Here you can see account identifier. This is your account identifier. Enter that account identifier. Then click on sign in. Then enter your username. Akkem Sreenivas. Then password is, enter your password. That's it. These are two ways to sign into AWS Cloud. So you can use dedicated URL, or you can enter app.snowflake.com, enter your account identifier. It will takes you to your login page. Then enter your username and enter password. Okay, clear, right? Team? Now let's see how to connect with Snowflake. Let me diagrammatically explain. Let's say this is my Snowflake. This is my Snowflake. This is my Snowflake. And let's say you may choose any of cloud. You may choose an AWS. You may choose an Azure. You may choose an GCP. AWS or Azure or GCP. So you may choose any of these clouds for your Snowflake cloud. You may choose any one of these. Let's say this is your Snowflake. How we can connect with the Snowflake? Yeah, first approach, we can connect Snowflake with Snowflake Web UI. So first approach is Snowflake Web UI. Using Snowflake Web UI, you can connect with Snowflake Cloud. So this is Snowflake Web User Interface. So we can use app dot we can use app.snowflake.com, then provide your account identifier. It will open a login page. You can enter your username and password. It will open this Snowflake web UI. So this is one way of communicating with the Snowflake cloud. Second one, I want to use clients like if it is MySQL, we use MySQL Workbench, right? If it is Oracle, we use SQL Developer. If it is Microsoft SQL Server, we use SQL Developer. There are plenty of tools available in the market to connect, sorry, to connect with Snowflake, RDBMS. You can use any popular RDBMS tool like DBever. You can use anyone like DBever. You can use DBever. And any popular tool. You can use either JDBC, you can use either JDBC or ODBC. You can use either JDBC or ODBC to create a connection between your popular RDBMS client with Snowflake. Then you can practice all SQL queries. Whatever you can do through Snowflake web UI, right? You can do almost SQL related only SQL related. You can write all SQL queries through this most popular tools. Next one, Tim. Next one. You can use programming techniques. You can use programming techniques, or you can use uh, programmatic approach. You can use programmatic approaches for connecting Snowflake team, like Java, Python, Scala, PySpark, Glue, etc., etc., to communicate with this Snowflake. So you can also use JDBC or ODBC to communicate with Snowflake. Second one, Tim. Next important one. Let's say there is a tool called SnowSQL. There is a tool called SnowSQL. You can install this SnowSQL. You can install SnowSQL, and this is command user interface. This one is a command user interface. This one is a command user interface. You can install this one in either Windows or you can install on Linux. You can install on Linux. Then you can create a connection between your Snowflake cloud with SnowSQL. When we go SnowSQL, let's say my Windows machine, I'm having local file system data, or my Linux machine, I am having local file system data, or my Linux machine or Windows machine data is generating continuously. I want to move that data from my local system to Snowflake cloud. Then you can install SnowSQL. Then you can move your data from your system, local file system to Snowflake tables. These are different approaches. These are different approaches to connect to communicate with Snowflake, Snowflake environment. Clear writing, we have different ways for communicating with the Snowflake, and our practice purpose, we are going to see Snowflake Web UI. We are going to practice all our SQL queries, and we are going to use SnowSQL, and we are going to move our local file system data to Snowflake cloud. Yeah, let's continue, team. In this session, we are going to understand Snowflake Web UI, Web User Interface. I already logged into AWS Cloud team. Sorry, Snowflake Cloud. This is my Snowflake Cloud URL. Okay. So here, first important one, I want to practice. I want to practice. Here you can see plus symbol. Here you can see SQL worksheet and Python worksheet. Click on SQL worksheet. SQL worksheet. Here we are going to write all our SQL queries. Here we are going to write all our SQL queries. SQL queries. So this is our workspace. This is our workspace to write SQL queries. Okay. And next important point. This is our worksheet. You can create any number. You can rename. Let's say Snowflake fundamentals. Second one. Let's say here I written SQL query 1. SQL query 1. Then I want to run this query. To run this query, let me add. This is my Snowflake Web UI. Here I'm writing SQL queries. Then I want to run this one. So whenever you run, Snowflake is going to take that request, and here you have storage and you have processing. Okay. Let's say this SQL query is create table command. Create table command. Then for this table command related under storage, it is going to create a folder. It is going to create a folder with your table name. Let's say you return insert. You return insert query. Insert query. Then it is going to create a file under this folder. This folder. Next one. If you write select query. If you write select query. Select query. Then with various conditions. With X condition, Y condition, Z condition, group by, order by, etc. options you added in this select query. Then to process all these options, we need a processing. Yes or no? So for this, you can create different sizes. Virtual warehouse. Processing is generic terminology. Uh, generic terminology. Snowflake terminology is virtual warehouse one. Virtual virtual warehouse. You can create various sizes. Virtual warehouse one with two resources. Virtual warehouse two with four resources. Like this, you can create multiple virtual warehouses. How can we choose virtual warehouse? Here, if you observe, you can see compute underscore WH. Compute underscore WH. Here you can see X hyphen small. What is this small? This is two resources one. There are multiple plans, multiple plans. Uh, Later we are going to see how to create a virtual warehouse with required sizes. This is a default warehouse. This is a default virtual warehouse created by Snowflake for your account. For your account, for my account, for someone accounts. Whenever we create an account, Snowflake people creates one default warehouse size called X hyphen small. X hyphen small means two resources. Two resources comes as a free tier eligible for your account. You can also later we can create multiple warehouses with different sizes like two resources, four resources, eight resources, 16 resources, 32 resources, 64 resources. If you increase multiple resources size, let's say you are using 32 or 16, 32 resources one. For small query, you are using 32. For medium data, you are using 32. For very, very small data also, you are using 32. Then in under free tier, they given $400, right? That will complete very faster. So based on just a practical purpose, we are going to see how we can create virtual warehouse with different sizes. I always recommend for your practice purpose, go with compute underscore WH uh, X hyphen small resource. This is more than enough to practice your data. Second one, I want to practice with the small data, medium data, big data, means huge volumes of data with different sizes. Let's say I want to take one sales data, uh, I want to test with my query. I developed one SQL query. I want to check whether this query going to give better performance on different sizes of data or not. I want to test. So for sample data purpose, you can see here, you can see this Snowflake underscore sample underscore data. This is default database. Default database. Here you can see different tables with different sizes. So first one, see, these are different sizes. Expand this one. You can expand the table. Let's take one customer data. You can see 100 MB data. This is 100 MB data. This one. Let's go to another one. Expand this one. Go to tables. You can see customer. You can see 65 MB. Let's expand another one. Another schema. In this expand tables, in this select this customer, you can see 150 KBs. Let's expand another one, 100 KB. This one is 150 KB. Here, same table with more records. Here you can see, sizes 2.2 GB. First one is, you can see table here size. This one is 3.4 GB. 100 million records, 100 million records or rows. 3.4 GB, and this one is, you can see 2.2 GB. You can see this one, you can see 10 MB. Like that, they given smaller data sets with the bigger volumes of data sets for some default tables. You can write different SQL queries for transformations. Then you can check on this data. This is default data. Come again. No, I didn't say. We can test with different sizes of data. Column names. These are different column names. You are saying this one, right? This one, right? One minute. Select one. Hmm. Yeah, we'll discuss this one. No worries. Yeah. Hmm. Sure. Hmm. Yes, correct. Yeah. So to practice different size of data, instead of creating different sizes, they provided some default tables with different sizes. Okay. Along with this one, they provided some important tables for different purposes under Snowflake database with with different schemas. Next one thing. Next important one. Here you can see one more important one, account admin. Account admin. This one we call it as roles. There are some important roles. There are some important roles, predefined roles. Based on these roles, you can also create uh, uh, your own role. Then you can attach that role to user. Here you can see. Here you can see. Yeah. So here you can see this icon. They are modifying user interface team. So today you are seeing this screen. After 1 month or 2 months, they may add multiple new features. Here you can see users and roles. So default rows, while creating account, we given this username. This is our username, Akkem Sreenivasa. This is our display name. For this, they assigned role type is account admin. I want to know what are different roles are available. Here you can see roles. Here you can see currently some important roles. Account admin, organization admin, public admin, security admin, Snowflake learning, sysadmin, and user admin. This user admin, account admin is assigned to our user. We can also create roles. We can also assign roles to users. Later, while user management, we are going to see how to create roles, how to create users, how to assign roles, both in command and graphical approach. Next important one thing. I want to load the data. I want to load the data from different data sources. You can see this is the data symbol. Sorry, you can see. Yeah. So under plus symbol, you can see add data. Click on add data. They are giving graphical user interface to connect different data sources. Like they load data into table, load file into stage, and load data from AWS S3 to your table. Load data from Microsoft Azure Cloud Storage to your table. Load data from Google Cloud Storage to your table. And load data from Microsoft OneLake to table. Along with this one, you can see multiple connectors. You can click on more connectors. They are providing multiple connectors for different sources. You can use corresponding connector. You can connect to corresponding source. You can load the data into Snowflake data warehouse environment. Okay. You can click on plus symbol. You can see. And next one, if you want to write a Python code, you can click on Python worksheet. You can write. You want to create a user interface. User interface. Inbuilt inbuilt Snowflake providing one technology called Streamlit. Streamlit is like a HTML, and you may hear uh, in Python we have uh, web frameworks, multiple web frameworks. So Streamlit is one of the most popular web framework. web framework to create applications, user interfaces. So you can click on new Streamlit tab. You can develop a user interface to read your Snowflake data. And you can create connection to Git repositories, any Git supported repositories. And these are, we are going to discuss later, table stays view. Okay, important one is if you want to write SQL queries, you can create SQL worksheet. If you want to write Python programs, use this Python worksheet. If you want to create user interfaces, graphical user interfaces, use this Streamlit app. You can integrate your Snowflake with any Git supported repository. Okay, and you can load data from different sources. And here you can see other options. Let me, so here, so here you can see warehouses. So this one is the default warehouse for user practice. So standard and size is x-small and only one cluster. Okay. And we created SQL worksheet. So this is our worksheet. So clear writing this Snowflake web UI. And next, very, very important one thing. If you want to know about your user properties, you can see this icon, edit icon. Click on this edit, sorry, not this one. Let me move this icon. Here you can see your user. Click on user. Here you can see your user properties. So your user identifier is AD63471. So click on this AD63471. Click on view details. And these are your account identifiers. Account identifier and organization name and account name and account server URL, login username, role name. Okay. So we use this account identifier for creating connection between your Snowflake with multiple other tools. So these are very, very important account details team. So you can additionally see different additional options, but these are very, very important one. Yeah, let's starting. As part of Master Snowflake, in this session, we are going to discuss how to create databases, schemas, tables, and how to insert data into tables in Snowflake. Okay, so first let's start understanding uh, uh, database. Okay, before that, first we have to log into Snowflake web UI and then create a create a workspace. So here you can click on worksheet or you can create. And I already created a worksheet for Snowflake fundamentals. So this is my worksheet. Here I am going to write SQL queries. Okay. Next one. Understand what is database. Any idea what is database team? That is table. Table can be used to store data in a rows and columns format. Correct. But database, first let's understand. I am working for ICICI Bank. ICICI Bank project. Okay. And in this, they have they have core banking, core banking, and they have insurance. They have insurance, and they have mutual funds, and they have multiple other different projects too. Under under ICICI Bank, there are multiple projects. In each in each project, again, different tables. Different tables. Let's say uh, account, 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 customer, customer, etc. Multiple tables, multiple tables. So first let's understand it here. First let's understand for every organization, for every organization, we create a database. We create a database. For every project, for every project, we create a schema. We create a schema. And for every purpose, we create a separate tables. We created separate tables. Now let's understand. Schema is a collection of related tables. Schema is a collection of related tables. A database is a collection of schemas. A database is a collection of schemas. For every project, we create a separate schema, and for entire organization, we create database. So to create a database, we use command called create database name. I am creating sample DB. Let's observe here. I am creating sample DB. See here, no database is selected right now. And then when I execute this one, control enter, you can see database is created successfully. Refresh here, you can see sample database is created. Once database is created, you can see sample DB dot public. So under sample database, it will create one default schema called public schema. Along with this one, it created information schema. In the information schema, there are lot of views, and under public schema, we have no objects created. So whenever you create a database, it will create two schemas. By default, it will create two schemas. One is public schema, second one is information schema. Now I want to create a schema. Create schema, sample schema. I am creating schema called sample schema. Let's take this one. Let's see, create sample schema. Control enter. So refresh here. Now you can see along with the public, along with information schema, you are seeing sample schema is created. Under sample schema, I want to create a table. Then here you have a option of selecting your required schema, sample schema. Okay. You can select a schema, or we can use we can use use command. We can use command to switch from one database to other database, one schema to other schema using use command. Clear writing. Here, when I execute to create a database sample DB, then here previous execution of this command, you seen message saying no database is selected. Once I executed, I created sample DB, right? That's why it is selected sample DB. Yeah. So once a database is created, there are two default schemas created in any database. One is public, another one is information schema. Two, two schemas. Then I created sample schema under this database because database is selected. But how I selected this schema? Using manually I selected. Instead of that, you can use command to switch database to switch schema. Okay, now let's start understanding creating a table. So in this, I am creating let's see, I am creating table, create a table under sample schema dot customers and column name data type, column name data type, column name data type. So customer ID, first name, last name, email, created data when customer is created. So these are 5 columns. Let's select this SQL statement. You can execute to run button here. Click on run button or you can enter control enter. See, table customer created successfully. Let's refresh here. You can see sample schema. Under tables, you can see customers is created. Customer table is created. I'm just using simple select command. Select star from customers. Then I'm executing control enter. There are no records in this customers table. Then we can use insert command. We can use insert command to insert the data into table. Let's see. I am using insert command. Insert into table name and list of columns, values of each row separated with comma. And inside row, you can see tuple representation. Inside row, if it is numeric value, we represent directly. If it is string, we represent in single quote or double quote. Okay. Then select this insert command, control enter. Now data inserted successfully. Now I am selecting once again select query. I am executing. See, 2 records are presented. So total, how many records are presented? And let me add one important point here. For every query execution, right side below, you are seeing query ID. See, this is query ID. So for every query, it maintains history. Whenever you submit query in Snowflake, for every query, it creates one query ID. We are going to discuss very in depth about this query ID. Okay, it is very important uh, point to them. Query ID purpose we are going to use later. So for every query, it maintain a query ID. In query history, we can find list of queries we executed. That's what we can say. Let's say we are 10 people working and I executed multiple queries, you executed multiple queries. I cannot say I did not execute so and so delete query because every query having a history, query ID, who executed, then they can find who executed that delete query. So for every query, we have a separate query ID. Later, we are going to discuss what is the importance of this query ID. So we executed some list of commands. Okay? Let me execute one more select query. So select star, count star from uh, customers. It will return number of rows are 2. Number of rows are 2. Okay. Clear writing? So in this session, we have discussed how to create databases, schemas, tables, and insert data into tables in Snowflake. Yeah. Now let's continue master Snowflake. In this session, we are going to discuss SnowSQL installation and configuration on Windows and create uh, connection between SnowSQL and Snowflake team. Yeah, let me add some important points about SnowSQL team. This is my Snowflake. This is my Snowflake. My Snowflake backend may be AWS, maybe AWS, maybe Azure, maybe Azure, maybe GCP, maybe GCP. So my Snowflake backend may be any of these clouds. Okay. Then I created account into my Snowflake. Okay. Uh, I want to upload data from my local machine. Let's say I am using Windows machine. I'm using Windows. So in my Windows, I have multiple files. Windows, I have multiple files. I have multiple files. So I want to files into load these files into Snowflake table. Snowflake table. So here, what we are going to do is we are going to install. Yeah, let me explain. Here we use Snow SQL software. Snow SQL software. Snow SQL is a command user interface. Snow SQL is a command user interface. Using the Snow SQL, we can load local files from your local machine to Snowflake table. Okay, let's say I am using Windows machine. In my machine, I have lot of files. I want to load these files into Snowflake. Then in my local machine, I will. That's what I'm saying. Yes, that's what I'm saying. Your developer machine. Developer machine. So in developer machine, we have files and we want to move our files into Snowflake tables. Okay. So let's say uh, I am using Windows machine. Let's say Sreen was using Windows machine. And there is another guy working in the same project. Name is Badri. This Badri using Linux operating system. Linux operating system. In his Linux machine, he is getting local files. Local files. Then he want to move data to Snowflake table. He can also install SnowSQL. SnowSQL. He can move these local files to Snowflake tables. So Snowflake is a command line interface. We can install SnowSQL in Windows operating system. We can install SnowSQL on Linux operating system. We can install SnowSQL on Mac operating systems. Okay. So clear writing. So SnowSQL software available for Windows, Linux, and Mac operating system. Now let's understand. Now let's understand how to install SnowSQL and how to configure SnowSQL with the Snowflake. So open this URL. Open this URL. SnowSQL SQL developer. Then it will open a URL. That's right. Yeah. So developers dot snowflake.com. Then here you can see SnowSQL download. So here you can see uh, SnowSQL for Linux, SnowSQL for Mac, SnowSQL for Windows. I'm selecting Windows. Yeah. Click on Start Download. Then click on Open Folder. Yeah. So double click on this downloaded file. Double click on downloaded file. Click on Next button. Then it is installing under Program Files, Snowflake SQL. Click on Next button. Click on Install button. It will open a pop-up window. Click on Yes button. And don't click on Finish. Don't click on Finish. Observe here. Here, I said we can configure Snowflake, right? After Snowflake installation, we have to configure Snowflake, SnowSQL with Snowflake. Yes, sir. Here it is showing how to configure. First, open new terminal window, execute a command to test connection. SnowSQL -a account name -u login name. Let's see, clear the screen. Let me close this one. So what these guys saying? Open command prompt. Okay. So let me open command prompt. Then what these guys are saying? First, use snow SQL command -a account name -u username. Let's say Akkem Sreenivas. And tell me how to find account name. Go to Snowflake Web UI where uh, I'm typing, I'm typing Okay. I thought I need to write show account. Then this one account. Here you can see view account details. Here you can see account identifier. So this is account identifier. Go to command prompt, enter this account identifier. Press enter. Once this one, press enter. Then it will ask password. Enter a password. No, no. Account name, always we have to use account identifier. Yeah. Now you can see SnowSQL v1.4.5. Now you can execute any SQL command. So databases. So how many databases we have? Just now we created one database. What is that database name? Yeah, what is that database name? Sample DB, right? Clear, right? So, so use this account identifier. Account name means account identifier. Okay. So clear, right? So first we used yeah, Control D to come out from uh, SnowSQL. So this is the command to connect your SnowSQL. Once this one is completed, okay, so we can use this command. This command. Okay. Now, way to. So every time you have to use this command to connect. But my requirement is when I type SnowSQL, it has to connect automatically. It has to come connect automatically. If you see here, they given add connection information to //.snowsql/config file. If I type SnowSQL, then it will connect automatically. So where we can find that one? Where we can find that one? So first, what they are saying, // dot SnowSQL means current user. What is current user? Under C, users, Gen AI is current user. Go to C drive. Go to C drive. Go to users. Under this Gen AI, here dot SnowSQL. In this config, let's open config file. In this configuration file, you can see account name, Account name nothing but this account identifier. Okay. Then username is Akkem Sreenivasa and password is India @123 123 123. Save. Then close this terminal. Close this terminal. Okay. Click on finish. Now open terminal. Then type Snow SQL. So this time see it is always expecting -a, -u, -d, -s, some parameters. Then how we can resolve this one is we have to uh, give a this connection details names. Let me check, is there any parameters to tell about our config file? Before that, let's check, is it saved? Yes. Account name, username, and password. And yeah, one important point, team. Let me take this one. Control C, Control Z. Okay. Let me take this one. We have to use this one. Connections dot connections dot. Yeah, we have to give a name. Let's say Snowflake or Akkem Sreenivasa. Connections dot Akkem Sreenivasa. In this, I am giving connection details. Now, let's see, is there any -c, -a, -u, -d? Connection details about to connect to Snowflake without entering manually username and password and account identifier. We are providing in a configuration. For that configurations, we are giving a name, unique name. Yeah. So that we can provide multiple Snowflake connections. Yeah. See, -config file. You can give a config file. See, -c and connection text. Let's say Snow SQL. Snow SQL. I'm giving Akkem Sreenivasa. Yeah. Let me use connections dot Akkem Sreenivasa. See, we have option, hyphen C or hyphen connection and your username. So I entered SnowSQL hyphen C, that parameter name, whatever parameter we given here. So hyphen C, Akkem Sreenivas, it is connected to my Snowflake. So here you may have multiple Snowflake accounts. Then you can provide multiple parameters here. Then you can use this parameter to connect a particular Snowflake. You may have dev, you may have test, you may have production, you may have UAT. All connection details you can provide. Whatever environment you can connect using -C option here. Clear, right? How to install and how to configure SnowSQL? Okay. Yeah. Let's start in. As part of Master Snowflake, in this session, we are going to discuss creating connection between other clients like DBever with Snowflake. Let's see how to create a connection between different RDBMS clients we have, right? In that, most popular client is DBever. DBever, we use DBever for writing SQL queries, right? So let's create a connection between DBever to Snowflake. Then, then, then write SQL from DBever. Okay. So first important point is install DBever. So you can use any web browser. So in my machine, I have Google Chrome. I am opening Google Chrome. Then download DBever to your Windows operating system. The- Then here you can see DBever community version. It is free. Here you can see installable software. Click on this one. Then start download. Once download is completed, we are going to create a connection between DBever to our Snowflake team. So there are plenty of clients available. The most popular another client is DBever. Double click on this downloaded file. Okay. Double click on this downloaded file. Then select all default options. And here click on next button and click on I agree. Then select default options. Then click on next button. Then click on next button. Then click on, if you want to shortcut in desktop, click on this one. Click on install. Then it will take a few seconds time to install DBever in your uh, Windows operating system. Yeah. So installation is completed. Click on desktop in shortcut in desktop. Then let's say double click on this DBever. Double click on this DBever. And if you want to create a connection between DBever and Snowflake, you need a JDBC driver. How to download JDBC driver? We are going to see it. Okay. Then click on do not save. And now let's start creating connection between your DB ever with Snowflake. Go to database, go to database. Here you can see new database connection, and here search Snowflake. Search Snowflake. Selected Snowflake. Then click on next button. Then here you can see database name. So we have already some databases, right? Sample DB. Give a database name. Our database name is sample DB. Sample DB. Warehouse. Warehouse means this one, virtual warehouse. Compute underscore WH. Compute underscore WH. And schema. Schema is a in this sample database, we are using sample schema. Provide sample schema name. Then username is Akkem Sreenivas. Okay, and password. Password. Enter password. Okay. Now see here, role is optional right now. Then authenticator. How you can authenticate this Snowflake? So here, see Snowflake host. Snowflake host means our Snowflake account identifier. Let's select this account identifier, or you can see this server URL. Let's take this server URL. It contains account identifier dot snowflakecomputing.com. Let's enter this account URL. Then here you can see driver settings. Click on this driver settings, and here you can see uh, libraries. You can see Snowflake driver, and here you can see download and update. Sorry, download. We we need to download JDBC driver. Yeah. Now let's click on OK here. Then click on test connection. Observe. Uh, Again, it is asking download driver. Yeah. If it will ask, just click on download. Yeah. Now you can see connection to test. This is sample driver connected. Then click OK. Then click on finish. See, this is our Snowflake sample. In this sample, we have public sample schema. In this, we have one table. What is the table name? Customers. Okay. You can see these are columns. Yes or no? There are two records. You can see we find two records. Clear? How to create a connection between DBever with Snowflake. Once you created a connection with DBever, then you can write all SQL queries from DBever. So we seen this is our Snowflake, and Snowflake backend we selected AWS. Snowflake backend cloud I choose it. Maybe you can choose any cloud. In this storage is S3 and processing is EC2. EC2. Now we seen web UI. We seen web UI. We seen connection between Snowflake with Snow, SQL. We seen this is web UI, okay, and we seen SQL. We installed SQL. We created connection between Snowflake. Then it is a command user interface. And again, we seen one of the most popular client called DBever. Okay, DBever. Then we created connection. So we seen different clients to connect to Snowflake for writing. It may be web UI. It may be web UI. It may be SQL. We write SQL queries. We write SQL queries to interact with Snowflake. Clear writing? What are different clients available? How to create a connection between Snowflake and how to write SQL queries. You can use any. I'm going to use web UI. You can use any for your practice purpose. Yeah, let's start in. As part of Master Snowflake, in this session, we are going to uh, start learning SQL for Snowflake. SQL for Snowflake. Till now, we have discussed Snowflake fundamentals, and then we enter into SQL part now. So as part of SQL for Snowflake, especially I created this topic for who do not have knowledge or exposure on SQL or any RDBMS. Let's say I am completely newbie and I want to learn Snowflake. You can happily learn. Only one prerequisite you should know is SQL. So instead of learning SQL separately, as part of our Snowflake, we are covering. So these are 8 topics we are covering. Let's say first we start with understanding what is SQL. SQL contain some sub languages like DDL, DML, DCL, TCL. What are different sub languages available? What is the purpose of each sub language? Then we are going to discuss different SQL concepts like data definition language, data manipulation language, data query language, sorry, DRL, data query language, data retrieval language, transaction control language, data control language, and writing filter queries with different where conditions, with different filter options. Then we are going to see different SQL commands, SQL examples on Snowflake. This SQL part will give clear idea how to write SQL queries, how to write SQL queries in Snowflake environment. So first important language you should know to communicate with the Snowflake is SQL. So SQL, these are main important concepts. Along with there are multiple concepts in SQL, but these are very, very important for interacting with the Snowflake. So my request to who do not have knowledge on SQL. So once you complete this 8 topics, 8 chapters, start exploring in-depth knowledge on SQL. How much in-depth knowledge you can have, you can easily work on Snowflake. Along with SQL, you need to have additional Snowflake concepts. Once we complete this SQL, we are going to start it. Okay, clear, right? What are concepts we are going to cover as part of Master Snowflake, SQL for Snowflake? Okay. Yeah, let's continue Master Snowflake. In this, we are continuing SQL for Snowflake. In that, let's start understanding what is SQL. SQL is a SQL full form is structured query language. SQL language can be used to communicate with any RDBMS database. Any RDBMS database. RDBMS full form is Relational Database Management Software. And there are plenty of relational database management softwares like MySQL, PostgreSQL, Oracle, and there are plenty of RDBMS softwares available in the market. Every RDBMS supports SQL, ANSI SQL. As ANSI SQL is common language to interact with RDBMS. Maybe some commands little different syntax, but all RDBMS supports SQL concepts. Not only RDBMS, all data warehousing also supports SQL, like Snowflake, Redshift, and many other data warehouses supports SQL. So SQL also can be used to interact with Snowflake. This SQL again divided into 5 sub-languages. This SQL again divided into 5 sub-languages called DDL, DML, DRL, TCL, and DCL. DDL, DML, DRL, and TCL and DCL. Let's say this is my Snowflake. This is my Snowflake. In this Snowflake, I want to create a user. I, I want to create a table. I want to create a view. I want to create a view. I want to create a procedure. And after creation, if I want to modify definition, let's say I want to change data type of a column. I want to increase column uh, column size. I want to change data type. I want to rename column. Or if you want to modify, or if you want to alter definition. Next one, I want to drop entire definition. I want to drop user. I want to drop table. I want to drop a view. I want to drop a procedure, etc. So to create a definition, to alter a definition, to drop a definition, we use data definition language. Data definition language. Next one, definition is presented. We want to insert the data into table. We want to update the data into table. We want to delete records from table. Then we have another language called data manipulation language. Next one, we created definition. We inserted data into table. Now my requirement is I want to read based on my requirement. I want to read all records. I want to read few records. I want to read based on condition, and I want to perform calculations on the read data, and I want to apply different conditions. Then we have DRL, data retrieval language, or data query language, and other one TCL, transaction control language. Let's say from this Snowflake, from one server to another server, we are moving data. Let's say here, let's say this is HDFC Bank, HDFC Bank. Here, ICICI Bank. Let's say user transferred money from this bank to this bank. Assume. Then here date money is deducted. Here money is not deposited. I want to cancel the transaction from first server one. Then we have a transaction control language. We have commit and rollback. If transaction successful, we use commit operation. If transaction failed, we use rollback operation. Next one, we have multiple users. Let's say 5 developers are working for X project and 2 testers are working and 1 administrator is working. For developer, we want to give create and read permission. Create and read permission. For tester, we want to give only read. For administrator, we want to give create, read, and delete. And here we want to give update also. And delete and update also. We want to give it to administrator. So based on their role of a user, we want to give a permissions. So DCL is a data control language. It contain commands to grant access on your database objects and revoke or cancel privileges privileges to your user. These are 5 important sublanguages of SQL team. These are common for any RDBMS, any data warehouse, including Snowflake. So every database, every data warehouse understands SQL. That's why it is very, very important to know SQL. Very, very important to know SQL. Whether you are coming from RDBMS background, you are coming from programming background, you are coming from admin background, you are coming from testing background, or you are completely newbie, you do not have complete any computer science knowledge to interact with Snowflake, you should have a SQL knowledge. That's why we are going to discuss these SQL language with different practicals on these 5 sub languages. Okay. So my request is once you complete this SQL, start exploring in-depth knowledge on SQL. So first they will start asking Snowflake concepts. Once you clear Snowflake concepts, then they start focusing on SQL. First filtration is Snowflake concepts. Next filtration is SQL. And later, based on additional concepts you are putting into your experience. So these are mandate. Yeah. Let's continue, team. As part of Master Snowflake, we are discussing SQL for Snowflake. In that, let's continue data definition language for Snowflake. Data definition language with examples for Snowflake. Okay, let's start discussing. As part of data definition language, we, we have 3 commands team. One create and second one alter, third one drop. Create command can be used to create table, create a database, create a schema, create a procedure, create a user, and create a view, etc. So to create any Snowflake object, we use create command. Next one, alter command. Let's say we created a table. We want to rename a table, or we want to rename a column, or we want to change a data type of a column, or we want to increase size of a column. So you can use alter command to modify the definition. Create can be used to create a definition. If you want to alter or modify a definition, we use alter command. If you want to drop definition completely from Snowflake, then we use drop command. So these 3 commands are very, very important commands in data definition language. So to implement this data definition language, first we need to log in Snowflake. I already logged into Snowflake. Let's start creating a database. I am creating database called RawDB. So first I am creating RawDB. Okay. Then select this command, Control Enter. You can see RawDB is created. Under RawDB, 2 schemas are created automatically. Okay. Then my requirement is I want to create my own schema. So I am creating raw schema. Let's say create schema. raw schema. Create schema, raw schema. Let's say if a database is selected different, then this schema is going to create in different database. That's why use database and database name to switch from one database to other database. So I'm switching to raw DB. Then I am creating schema called raw schema. Then you can refresh. You can see raw schema is created. Once you execute command, you can see active schema raw underscore DB raw underscore schema. In this, I want to create a table. So table name is employees. Table name is employees with different columns. Let's say ID integer type, name string type, age int type, department string type. So total 4 columns I am creating. So table is created successfully. Okay. After table creation, I got a requirement to saying add a new column. Then we can add new column to existing table using alter command. We can add a new column to existing table using alter command, add column option, then add a new column. Then, sorry, table is created and you can see table. You can see definition of this table and details of this table. Clear, writing? How to create a table, how to alter a table. Next team. I want to rename a schema. Sorry. I want to rename a schema. Then we can use schema name. We can use schema name. So alter schema, old schema name, rename to new schema name. You can refresh here. So raw underscore schema is renamed with new underscore raw underscore schema. Okay, clear, writing? And next, I want to drop a table. Then you can use drop table, table name. It will delete definition of this table permanently from Snowflake. Yeah. So here, use schema. Schema name is new schema. Then delete this table. So table is deleted successfully. I want to delete a database. You can delete directly. If you want to delete schema also, you can delete schema first. Next, you can delete database. When I drop database, it will drop tables. It will drop schemas automatically. Okay, if you drop table, table only going to drop. Remaining everything is presented. If you drop a schema, both the table schema definitions are going to delete. If you drop database, it will delete entire structure. Okay, clear, writing? Clear, writing? This DDL commands. Okay. Yeah. Yeah. Let's continue master Snowflake. We are discussing SQL for Snowflake. Let's start discussing DML commands with examples for Snowflake. DML means first, importantly, data definition, DDL. Using data definition language, we created a definition. Let's say table. Once a definition is created, then we want to insert the data and we want to update the data or we want to delete the data. We want to delete entire data. So to perform operations on the data, definition of data, we use DML. DML stands for data manipulation language. As part of data manipulation language, we have four commands: insert, update, delete, and truncate. Let's see. Create command can be used to create command can be used to create a table. Let's say I am creating table. Before that, let me create a database and then DML. Okay. So I am creating a database and I am creating schema and then I am creating table called raw table. Sorry, employees table under raw schema. Okay. Yeah. So now let's use insert command. Insert command to insert the data. Insert command is from DML language, data manipulation language. Let's see. Select this command. At a time you can insert at a time you can insert any number of records. So each record we put in tuple and record separation we use comma. Once you feel record is ended, then we put semicolon and insert command into table name and list of columns values of we give list of values. Okay. Yeah. Now we have a data. I want to see whether data is inserted or not. There is a command, data retrieval command. We will discuss this data retrieval later, but just to see whether data is inserted or not, we use select command and star from table name. It displays complete data of your table. So we are seeing two records are presented. My requirement is I want to update the data. Let's say 25 is completed, 2025 is completed. Let's say we entered into 2026. Then age is changed for different people. I want to change ages, means I want to update ages. Then we can use update command. We can use update command. We can change value of particular column. So for person ID 1 means this person, I am increasing age equal to 31. So let me select this command. Let's execute. See, one record is updated. Now I want to see whether record is updated or not. Select this select command, control enter. You can see previously age is 30. Now age is updated with 31. Next thing. Next one. I want to delete employee 1. Let's say employee left from organization. I want to delete record of employee. Then you can use delete command from table name where condition means column equal to column value. Then it will delete employee record from table. Let's verify whether employee 1 is deleted or not using select command. You can see we have only one record. Assume if you delete a record accidentally, then you want to revoke that record. We have concepts, time travel, we have fail-safe concepts. Using that, we can restore. Once we start discussing those concepts, I will explain how we can restore deleted records into Snowflake data warehouse. Okay. Yeah. Next one. I want to delete all records. I want to delete all records. We can use truncate table name. Then it will delete all records. Where condition in delete command, we specify where condition. Only specified rows it will delete. If you want to delete all records, then we can use truncate command. Let's verify data is deleted or not. You can see no records are present. If you want to delete the table definition permanently, we use drop command. If you want to delete satisfied records, we use delete command. If you want to delete all records, we use truncate command. Okay. Yeah. Yeah. Let's continue master Snowflake thing. In this session, we are going to discuss DRL, data retrieval language, or DQL, data query language for Snowflake. Okay. So in DRL or DQL, we have only one command called select. Select command can be used to retrieve data from retrieve data from table. Okay, let's see. I am creating one table called employee table with two records. Let's say I am creating table called employee table with two records. Let's say I am inserting data into the table, two records. Then my requirement is I want to see all rows and all columns. I want to see all rows and all columns. Then we can use select star from table name. So here star means all rows and all columns. Select star from table name. Here star means all rows and all columns. Let me execute. You can see all rows and all columns. My requirement is I want only few columns. Then you can specify column names instead of star. My requirement is only few columns, but all rows. Then you can specify column names. Next one, I want few rows, few columns. Then we can use where call, we can use where condition. So all rows, sorry, all columns, but few rows. Based on this filter condition, we want to display number of records. So only one record satisfied with A is greater than 25. I want few columns, few rows based on condition. Then select specify list of columns from table name, then write filter condition. Instead of all columns, it displays specified columns and satisfied rows. So in this way, we can write multiple filter conditions with select query. Okay. So in data retrieval or data query language, we have only one command called select. Yeah. Yeah. Let's continue SQL for Snowflake. As part of Master Snowflake, we are discussing SQL for Snowflake. Let's continue SQL utility commands. There are some common commands in SQL which are nowhere related to those 5 sub-languages. These are common commands. First command is use command. Use command can be used to switch from one database to another database and one schema to another schema. Let's say I want to switch to public schema. Use schema public. Then previously raw underscore db dot raw underscore schema is there. Now it is switched to public schema. Let's say I want to switch from raw underscore db to Snowflake schema. Just use database name, use database Snowflake schema. I want to switch to different schema. Let's say core schema. You can switch. See, in Snowflake, we have different schemas, core schema and public schema. We switched from core schema from Snowflake database. Then I want to again switch from Snowflake database to raw underscore db. Then I want to switch to raw schema. So by default, when you are switching one database to other database, by default, it will select default schema is called public. So if you want to switch another schema, then specify the schema. So clear, right? Switch use command can be used to switch from one schema to other schema, one database to other database. And next command, show command team. Show command can be used to describe table details, schema details, and database details. Let's say show tables. It will display complete table list from current schema selected. So here raw underscore db is selected. Under raw underscore db, raw underscore schema is selected. And in this, we have only one table. I want to know in current database, I want to know how many schemas are present. Then you can select show schemas. Then it will listing schemas. There are three schemas. I want to know complete databases list from my Snowflake account. Then it will list all database names. These are some important utility commands. And there is one more command, describe command. Describe command can be used to display definition of your table. Definition of your table means what is your table name and what are columns of your table, what are data types assigned for your columns, okay, whether that table column allows null value or not. Complete details it will display. Complete details it will display them. Clear, right? So these are common utility commands. Yeah, let's continue, Tim. As part of Master Snowflake SQL, we are continuing SQL for Snowflake. As part of SQL for Snowflake, let's continue TCL commands with examples. TCL stands for Transaction Control Language Commands with examples. There are three important TCL commands, Tim. One is begin, to begin a transaction, and other one is commit. If a transaction is successful, then we can use commit to save that transaction permanently into Snowflake. If a transaction not successful or failed, we can use rollback to revert the changes back to Snowflake. Okay, so these are three important commands in TCL in Snowflake. So any transaction we start with the begin. Let's say this is begin. Okay, and then I'm performing transaction called insert. Then I'm inserting three records sitting. Before that, let's open our Snowflake. Let's say enter begin, and before that select a raw DB and select raw schema. Then begin a transaction. Okay, yeah, transaction is started. Then what I'm doing, I am performing insert operation. Insert one record into table. Let's say select this insert command. Let's click on insert. Then after insert, let's say transaction is successful. Once insert is completed, let's say transaction is completed. Then I am executing commit operation. Here I am taking simple scenario, insert. Then I am inserting one record. Then once insertion is completed, select only one line, then execute. Now transaction committed successfully. Okay, yeah. Now let's start verifying the data. For any transaction operation, begin and commit operation is mandated. Okay, so here we completed this one. Again, I'm checking this select query. Then once I selected this query, let's see, data inserted successfully. But my requirement is what I want to do is another example. I started a transaction, then I modified employee age. I modified employee age. So assume instead of modifying one employee, accidentally I modified other employee. I want to cancel that transaction. So transaction started using begin. Then I did this mistake. I want to revert it. Then we can use rollback. We can use rollback to cancel the transaction. Okay, let me execute this one. Let's say execute this command, rollback. Then let's execute select query. You can see we got previous is. So any transaction in Snowflake, we start with begin. Begin. Here we write transaction. Transaction means one SQL statement. Let's say SQL statement. Then if this SQL statement we want to save, this SQL statement changes, we want to save permanently. We use commit operation. Commit operation. Let's say we do not want to commit these changes. This SQL statement, let's say, is wrong statement. Then instead of commit, we can use rollback. Rollback. So to cancel transaction. If you not start begin, then it won't work. So under begin, under commit or rollback, whatever the changes you did, if you want to change the changes permanently into Snowflake, we use a commit operation. If you want to cancel that SQL statement results, then you can use rollback. Okay, clear writing? Yeah, let's continue Master Snowflake. As part of Master Snowflake, we are discussing SQL for Snowflake. Okay, as part of SQL for Snowflake, let's continue data control language commands with examples. There are two commands, grant command and revoke command. Let's say this is my Snowflake, and I chosen Snowflake backend is AWS cloud. Okay, I created user username is Akkem Sreenivas. So this is my username. At the time of account creation, I used this username. So this user is main user or main admin user. Main user. So we cannot share this user credentials to every developer or every tester or every administrator. So instead, we are going to create different users. Let's say user 1 to user n, user 1 to user n, and for every user, let's say there are 5 users. Sorry, they are developers. There are 2 users. These users are testers. Testers. There is another user. User 8 is a admin. So based on their role in the project, we want to give privileges to the users. Yes or no? Using DCL commands, we can we can grant privileges to users. So first we create a role. Let's say here we have 5 users. For 5 users, we want to assign same grants. So create a role, then assign policies or privileges to role, then attach role to user. If you want to cancel any privileges from roles or users, we use revoke command. Yeah, let me show you different examples to create roles, grant privileges to roles, and revoke privileges from roles. So here, first we are creating a role. Create a role, my role. Let me create a role. So I am creating 2 roles. I am creating 2 roles. First I am creating my role. Then I am creating another role. Then I am trying to give access or privilege on role. Let's say here grant select on table employees to my role. Another one, grant insert update on table employee to role another role. For one role, we are giving only select. For another role, we are giving insert update operations on table employee. Let me grant to another role. Second one. Here we given privileges on table. Similar way, you can give privileges on schema level. We can give privileges on schema level. We can grant privileges on database level. So if you give privileges on table level, that role contain only table level. So other tables that roles do not have access. If you give schema level, we will create tables, we will create views, we will create functions. So if you give schema level, then that role contain access of tables, views, and functions. If you give database level, a database contain multiple project. For every project, we create a separate schema. So if, if you are giving privileges on database level, you get multiple schemas privileges. Yeah, let me. First one, let's say this is my ICICI database. ICICI database. Let's say we create a database called ICICI. In this database, we have different schemas. Let's say one schema is core banking. Core banking schema. So let's say this is schema. And similar way, it contain other schemas like insurance schema. And other one, we have mutual funds schema. Here, let's say if you give grant on table one, let's say here we have 100 tables. Let's say we have 100 tables. So if you give grant on this table, then this grant works only for this table. If you give schema level grant, it is for all tables presented in this schema. If you give database level grant, it is for all schemas, under all schemas, whatever presented. It applies for all. So same commands, you can use grant command to give privileges schema level and uh, table level and database level. So grant uses on schema, raw schema to my role, and grant all on schema, raw schema to another role. Yeah. So here, so clear writing. So if you want to assign role to user, first user should be exist. So create a user with a password, then grant role to that user. So a role can be assigned to multiple users. Example, there are 5 developers. For all developers, we created role dev role. Then we assigned privileges to that role. Then later we can grant that role to user so that whatever privileges we attach it to that role, then user get all those privileges to all those users. Yep. Let's start in. As part of Master Snowflake, let's start understanding AWS for Snowflake syllabus. And what are we are going to discuss? What are we are going to discuss? Okay. Uh, uh, let's say, yeah, let's continue, Tim. As part of Master Snowflake, we are going to continue AWS for Snowflake. In this, let's understand what are we are going to cover as part of Snowflake team. Let me why we are discussing AWS for Snowflake. Let's say team, this is my Snowflake account. Snowflake account. For this Snowflake, cloud may be anything. Cloud may be either AWS, backend cloud may be Azure, Azure, backend cloud may be GCP. So backend cloud may be any of these, or backend cloud may be GCP. Okay. So we created Snowflake account. Snowflake account. So now let's understand uh, why we are discussing AWS for Snowflake. Let's say in AWS cloud, in AWS cloud, there is a storage service called S3. There is a storage service called S3. Okay. In this S3, we have we have data. We have data. So we want to ingest data from Snowflake, sorry, AWS S3 to AWS S3 to our Snowflake table. This is our requirement. This is our requirement. Ingest data from S3 to Snowflake. Okay. So here, what are required from Snowflake to connect S3 location? So first, you need an account. Yes or no? So first, you need an account. Second one, you need to understand what is free tier. For working with AWS, what is free tier? How can we utilize free tier for our practice purpose? Next one. Next one. We need AWS EC2. Why we need AWS EC2? Let's say uh, EC2 can be used to create a virtual machine. EC2 can be used to create a virtual machine. Let's say in EC2, somewhere data is somewhere it is coming from, means in EC2, we call this one as a local file system. Local file system. To copy this local file system to Snowflake, then we use SnowSQL. We are going to install SnowSQL. We are going to install SnowSQL. Then we are going to move data from here to here. Next one. If you want to access EC2, if you want to access S3, we need one more service called AWS IAM. Using AWS IAM, authentication and authorization, then only from Snowflake we can connect with the different services. So that's why we are going to discuss EC2, we are going to discuss S3, we are going to discuss AWS IAM, and we are going to understand what is what is AWS, history of AWS, and AWS global infrastructure as a AWS fundamentals. So that's why we are learning to move data from AWS location to our Snowflake location. Whatever concepts required to know from AWS side, we are going to discuss all those concepts. These are more these are more than enough for interacting Snowflake to AWS, AWS to Snowflake to. See that these are main important concepts. If you want to learn any other concepts, your wish, you can also add more AWS cloud knowledge, but these concepts are more than enough for Snowflake developer. Okay? Yeah, yeah. Let's continue Master Snowflake. As part of this one, we are continuing uh, AWS for Snowflake. In that, let's understand what is AWS. So first point, AWS full form is Amazon Web Services. As one of our friends said, it is correct. And someone said it is a cloud computing platform. Yes, it's 100% correct. It is a cloud computing platform. And it provides infrastructure as a service. Some of our friends said infrastructure as a service, platform as a service, and software as a service. Correct. And one of our friends said it introduced solve problems of on-premise. Yes, you are 100% correct. What are problems associated with on-prem? Let's say I want to I want to develop a application. Let's say I'm developing e-commerce application. E-commerce application. Okay, e-commerce application. Then my expectation is initially I will get lakhs of customers or crores of customers. My assumption. So what I did is I taken a data center. I taken a data center. In this data center, I set up I set up 500 missions. 500 missions. So I need to purchase hardware. I need to purchase data center space, or I need to take data center space for rent. And I need to install the required softwares. I need to recruit different administrators to manage this cluster available 24 by 7. I am also thinking, let's say I set up this data center in North Hyderabad. I am thinking if North Hyderabad faces any issue, still I want to give access to my customers. So same thing I set up in South Hyderabad, I set up in East Hyderabad. If North Hyderabad completely not available, I can access from other data centers. Then 1500 computers I set up. I purchased, installed. For installation, I paid a lot of licensing cost, recruited many administrators to manage this cluster available for 24 by 7. Then what happened? Initially, until 1 year, there are very, very less customers. It is count in fingers, means maybe hundreds to thousands max. But my expectation is crores of customers. But I got only few customers. To serve few customers, these many resources are not required. One or two missions are more than enough, but we invested lot. Yes or no? So to avoid all these kind of problems, cloud computing systems were invented. What basis these cloud computings, especially like AWS will work? Pay as you go basis, on demand services, on demand services, pay as you go basis. Let me add these 2 points. On demand services, pay as you go basis. In AWS, let's say this is my AWS. This is my AWS. In AWS, in availability zone 1 means data center 1 in Mumbai region. In Mumbai region, availability zone 1 means data center 1. Then I taken only 2 missions. I taken only 2 missions initially and deployed my application. Deployed my application. For backup, for disaster recovery, I set up in availability zone 2 also. And I also set up in availability zone 3 are replicated. So we are saving cost. We are paying only how many resources we used. All of a sudden, my customers are increasing. Maybe after a month, after 2 months, day to day, my customers are increasing. You can configure load balancing. You can configure load balancing. You can configure auto scaling feature. Dynamically, you can add multiple resources. Dynamically, you can add multiple resources based on the load. If load is reduced, you can remove resources. If load is increased, you can add resources. Let's say morning 6 to 10, multiple people are coming, 10 resources are used. From 10 to evening 6, only few people, 2 resources are used. And from evening 6 to night 12, many people are connecting. That time 15 missions are used. How many resources used for your application? They calculate, they generate a bill. You no need to set up a cluster with multiple resources. And next point, you can avoid administrator cost. Let's say if it is on-premise, data center management, power related admins, operating system related admins, network related admins, lot of IT cost, administration cost we can avoid. Those are taken care by AWS people. We focus on our application. We least bother about infrastructure, licensing cost, operating systems cost, and administrators cost, data center maintenance cost. We least bother about those things. Those things are taken care by AWS people. We pay rent and we pay as you go basis. Means how many resources are used. We pay only for that. You can scale your resources and reliability. You can set up in multiple availability zones. so that if entire availability zone not available, we can access from other availability zones, and it is cost effective. If you have a less customers, you can configure load balancer, auto scaling feature. Based on your load, it reduces resources, it increases resources so that you can reduce cost. Let's say morning 10 a.m. to even 6 p.m. Very people are using my application because all people are going to offices. There very less people are using. Then I need only two missions. Such kind of load balancing, auto scaling feature you can enable. You can increase, decrease resources dynamically so that we can reduce cost. Along with AWS, there are many cloud vendors available. Azure, Google Cloud, IBM Cloud, Oracle Cloud, etc. Okay, clear, right? What is AWS? Yeah, yeah. Now let's understand key features of AWS team. Yeah. Any idea what is scaling? Just now we discussed scalability. Can anyone tell me what is scalability? Scaling resources based on demand. Example, example, mean I created one resource. Let's say I deployed X application in in let's say mission one. Mission one. I used load balancing. I configured load balancing and I configured auto scale. Auto scale. In auto scale, let's say I configured min min is 1 and let's say max I configured 500 missions. 500 missions. Okay, let's say multiple customers are connecting into this system. Then I created a load balancer. Let's say load limit, let's say at a time, let's say 1000 load, 1000 customers, 1000 people using this one. I need another mission to to support for more than 1000 people. Let's say threshold limit. Let's say 1000 interaction to my mission. More than 1000, I want another mission. So like that, it is creating multiple resources dynamically. Let's say when less than or equal to 1000 people are there inactive, then remaining systems released automatically. If load is increased, resources are created. Load is reduced, resource going to release, called scalability. Also, we have vertical scalability called in a single mission, we can increase RAM size, we can increase number of CPUs, we can increase hard disk space by adding volumes. Vertical scalability means single system. Horizontal scalability means multiple missions dynamically adding. Next one, security. In AWS, in AWS, we have a special service called AWS IAM. AWS IAM. let's say we have we have 12 developers. 12 developers. Okay. 8 data engineers. 8 data engineers. 2 testers. 1 administrator. 1 administrator. Based on these roles, based on these roles, I want to give access of AWS. AWS currently offering 200 plus services. AWS currently offering 200 plus services. 200 plus services. I do not want to give access of 200 services for 12 developers, 8 data engineers, 2 testers, and 1 administrators. Based on their role, I want to assign policies. I want to assign policies. So here we can create users. Okay. We can create groups. We can assign policies to users and groups. So first level security we can achieve using authentication and authorization using AWS IAM. And along with this one, let's say you want to store some software keys or password details, etc. things. We have special service called AWS KMS, Key Management Service. There we can store certification keys related, certificate keys related, and password related, etc. Sensitive information we can store. There are plenty of securities. These are some important. And next one, reliability. And first, flexibility. It supports multiple operating systems and multiple programming languages. Let's say I want to create a EC2 instance. I want to create a EC2 instance. In this instance, I want Linux. I want Windows. Under Linux, I want a different operating system. It has multiple operating systems. Next one. We have 200 plus services. I want to interact with these services. It supports Python, Java, .NET, Node.js, and plenty of programming languages. Plenty of programming languages. It is not fixed for particular programming language. Okay. And reliability. Very, very important one. Reliability. Let's say Mumbai is a region. In this region, minimum it maintain three availability zones. 3 availability zone. Availability zone means it is a data center in generic terminology. Data center in generic terminology. So in each region, minimum it maintains 3 availability zones. If one availability zone not available, you can access from other availability zone. Okay. Hmm. Same data only. Yeah. If you are storing data, then think about the data. If you are you are deploying your application, think about resources. Let's say I'm deploying my application. Instead of in a single availability zone, same application I deploy in another availability zones. So that if one availability zone is not available, then we can connect to another availability zone. AWS people given opportunity of availability zones, but your application you have to set up in multi availability zones. Okay. Let me add one point here. Let's say take a Python programming language. They are giving scripting oriented, object oriented, procedure oriented, and modular oriented. You are asking Python people develops program for you. No, right? We have to develop program based on our requirement, right? Hello. We have to similar way. AWS people providing resources, services. You can develop based on your requirement. You can utilize this availability features. They are giving all the features. How you utilize is depends upon your requirement. If you take single availability zone for your mission, cost is going to reduce. Same application I want in another availability zone, another mission, or I want same application in multiple missions. Cost going to increase, but your application is available 24 by 7, whatever the reason happened. Let's say Mumbai South region completely suffering with the floods. So entire availability zone is not available, but still you can access, your customers can access your application because somewhere in some other availability zone, your application is running. Yes or no? So you are making, yeah, no, no, you are think about your application. Let's say e-commerce application, you deployed in this mission, you deployed in this mission. Application is same. Application, you are always thinking about application going to store this data. You are thinking this one, you are not thinking about your application. So always you are thinking about storage. Before that, who is going to process your request? Your application, right? Again, I am coming to your point. Storage. Storage also, let's say 200 missions you set up. You set up. Some missions you replicate in availability zone 1. Some missions you are going to assign in some other missions. Then you going to duplicate your data into multiple missions so that you can access your storage also. First level application we are setting in multiple missions. Similarly, storage also you are setting in multiple missions in multiple availability zones. And even we have a cross zone option. Cross zone in the sense, let's say this is Mumbai region, another region is Canada, another region is, let's say, US, another region is UK. UK. Mine is banking application. Mine is banking application. My client is bank client. If if entire region is suffering problem, still I want to make my application available to my client. Even though budget is increased, they do not care about budget. They are banking clients, financial clients, healthcare clients. Data is very, very important for them. Applications should run up and run, and data should available 24 by 7. Let's say if 1 second or at least let's say 5 seconds server is down, they lose lot of money. For them, money is not important. Application should available 24 by 7. Then they are going to replicate applications in multi-availability zones, cross regions also. Even though that is expensive, but but they want to make application available 24 by 7, 365 days. They spend money. Okay, we have multi-availability zones replication and we have a cross region. We can replicate into another regions also to make applications or storage available 24 by 7, 365 days called reliability. At any cost, any failure situation happen, we want to make our application and data available to their customers. Okay, there are plenty of reasons because of people moving from on-premise to cloud, like AWS. Yeah, let's continue Master Snowflake. As part of Master Snowflake, we are discussing AWS for Snowflake. As part of AWS for Snowflake, let's understand history of AWS team. Yeah, AWS initially started with the first service called AWS S3. AWS Cloud currently providing 200 plus services. AWS Cloud currently providing 200 plus services in different categories. Different categories like infrastructure as service, software as service, platform as service. Currently, it is providing 200 plus service. So initially, it started 2002 and then it launched first cloud service, uh, Amazon S3, and they added EC2 later. So these two services called first services in AWS cloud. Initially, they started storage service, then uh, virtual mission service called Amazon EC2. And later, they added multiple services. Currently, 200 plus services they have invented. They have invented. Okay, next one. Next one. AWS providing uh, these 200 services in different categories like infrastructure as service and administration purpose. We can say admin and DevOps purpose, data analytical purpose, data engineering purpose, and data science purpose, IoT purpose, quantum computing purpose. For different categories, they are providing different services. For example, data engineering. They have S3, Kinesis, AWS Athena, AWS Glue, AWS Redshift, etc. So like that, different categories and different purposes, they providing different services. Okay. So AWS Cloud is the leading cloud vendor compared to other clouds like AWS, Azure, GCP, etc. Okay, you can see at the time of 2021, from 2021, it is providing 200 plus services. It started with these two services, but right now there are 200 plus services, including latest technologies like quantum computing, artificial intelligence, etc. Okay, clear writing? Yeah, yeah. Let's continue AWS for Snowflake. As part of Master Snowflake, we are learning AWS for Snowflake. In that, let's continue AWS free tier. We just now understand AWS account creation steps practically. Now let's see understanding AWS free tier. Let's say I am a Snowflake developer. I want to use AWS S3 and I want to use AWS EC2 system, EC2 service, and I want to use AWS IAM. So these three are very, very important for my uh, Snowflake integration with AWS. These are main important. I want to know, whether these services comes into free tier or not. If it comes as a free tier, then what are limitations? Such kind of things I want to know. So let's start understanding AWS free tier. So you can see aws.amazon.com/free. You can open this URL in any browser. Let's say I am opening here. You can see here, you can scroll, you can see under 200, and these are 187, 8 pages. In 8 pages, total 187 services. They are given complete free tier details. You can select each service and you can get more details about free tier. Or, or nowadays we have a powerful GPT tools like Chat GPT, and we have powerful GPT tools in the market. You can choose any one GPT tool. You can ask GPT about the free tiers and limitations. They connect this kind of websites and they will generate a nice explanation for you. Okay. Yeah. 1 minute. Yeah. Let's continue Master Snowflake. In this, we are discussing AWS for Snowflake. Let's start discussing AWS EC2 step-by-step guide to create AWS EC2 instance, launching Ubuntu operating system, and then connect AWS EC2 instance. Okay, these are the steps we are going to discuss in this session thing. So first, in AWS Cloud, we are going to create EC2 instance with Ubuntu operating system in our mission. This may be developer mission, this may be admin mission, this may be tester mission. Here we are going to use different client softwares like Putty, mRemoteNG, MobiXtem to connect our Ubuntu operating system team or Linux operating system on AWS EC2 mission. So for this, we follow some important steps. Team. Let me let me explain. First one, first one. In AWS Cloud, to create a virtual mission, we have a service called EC2. We have a service called EC2. First point, EC2. Using EC2, we can create a virtual machine. Okay. Next one. You can select any operating system you require. Let's say I want Ubuntu operating system. And then how we can connect to this EC2 machine is in our mission, we can install softwares like Putty, mRemoteNG, or MobiXtem. Any one software you can install, you can create a connection between remote mission. To create a connection between this one, we use a protocol called SSH, Secure Shell Protocol. So usually, if you want to enable SSH port number in operating system, we use a Linux command to enable a port number. But instead of that, in AWS, we have a concept called security group. We have a concept called security group. Using security group, we can enable port number. SSH port number is 22. We have to enable this port number so that our request to go through the security group to our mission. Next point, team. Next point. To connect to this operating system, we need a username and password. We need a username and password. AWS provides username instead of password. It have a concept called key pair. It have a concept called key pair. So you can create a key pair and you can attach key pair to any one of this tool. Then you can enter username. Then it is going to connect to Linux machine. So let's start this step-by-step process for creating EC2 instance and connecting EC2 instance. Let me explain it. Yeah. First one, login AWS Cloud. Login AWS Cloud. Second one, navigate EC2 instance. Navigate EC2 instance home page. EC2 instance page. Second one, and third one, create EC2 instance. Create EC2 instance. So let's follow these steps. So open any web browser. I am opening Google Chrome and here enter aws.amazon.com and here you have to click on my account, click on AWS Management Console. Here we have a option root user. Enter your root user email ID. While creating AWS account, we will provide email ID, right? We have to use that email ID. We have to use that password to log into AWS Management Console. Yeah. First, I completed this step one, log into AWS Cloud. Log into AWS Cloud team. So first step, what I said, login AWS cloud. Second step is navigate EC2 service. Navigate or open EC2 dashboard. So for this one, you can see in recently visited, I am able to see EC2, but in your case, you may created account recently. Then go to search bar, type EC2. Then click on this one, open in new tab. Open in new tab. This is EC2 dashboard. So we navigated EC2 dashboard. Create EC2 instance. Create EC2 instance. EC2 instance. Create EC2 instance. Okay. So click on instances, and here we have an option called instances, and here give a name. Let's say I'm giving name is Snowflake underscore EC2 underscore demo. I am creating EC2 instance for Snowflake, so I'm giving naming convention like this. Okay, you can give any name. Let's say you can give Sreenivasa, you can give Akkem, you can give your name, you can give any name. Okay, I am giving Snowflake underscore EC2 underscore demo. Then you can select required operating system. Here it is showing lot of operating systems. I want to create EC2 instance with Ubuntu. Select Ubuntu operating system. Then here you can see operating system Ubuntu server 24.04 LTS. This is the latest operating system of Ubuntu. Okay. It may change while you are going to practice, but right now the version is 24.04. Then below you can see T3 micro. T3 micro is eligible for free tier, and they are giving two virtual CPUs, 1 GB RAM. Two virtual CPUs, 1 GB RAM. And below you can see key pair. Click on create key pair. Click on create key pair. And here you can see two different algorithms, RSA and ED25519. Select a default one, give a key pair name. I'm giving key pair name Snowflake underscore key pair. Snowflake underscore key pair. Okay. Then here we have two different format of encryption file formats. One is .pem, one is .ppk. So here we have EC2 instance, EC2 instance, and in this we have installed Assume. We are selecting Ubuntu operating system. This is my developer mission, and this is your mission, and this one is someone's mission. So in this they are using putty, and in this they are using mobile XTEM, SSH client, mobile XTEM, and in this third mission they are using OpenSSH. All these are SSH clients to connect remote missions. SSH clients are responsible to connect these missions. Okay. So here putty supports .ppk and mobile XTEM supports .ppk file format. Then OpenSSH supports .file PEM file format. Different SSH SSH clients supports different file formats. All SSH supports either .pem, .ppk. In this, I am going to show connection between putty or MobiXM. I am going to show this one. That's why I am going to download this ppk file. Okay. Yeah. Hmm. These are encryption algorithms. Encryption algorithms. You can choose any one, but the format of encryption is different. So algorithm to algorithm, encrypted format is different. So you can browse or you can uh, chat, you can prompt GPT. They give you differences, but for us, these are encrypted formats. So I am selecting dot ppk because I may going to use a putty or mobile extern. You may have a one question. Let's say today I am using putty or mobile extern. Tomorrow, let's say I want to use OpenSSH or Microsoft remote desktop SSH client. Then those are going to support .pem format. But today I downloaded PPK. Can I convert .ppk to .pem? Yes. There is a software called Puttigen. Using Puttigen, you can convert .pem to .ppk, .ppk to .pem, vice versa. There is a software called Puttigen. Using that Puttigen, you can convert to ppk to pem, pem to ppk. Okay. So I selected .ppk, click on create. You can see here it is downloading. It is downloading. Snowflake underscore ppk. Okay. Okay, Tim. Yeah, Tim. It is downloaded in this location, Snowflake underscore key pair ppk. I am placing this one in my location under C drive. Under Akkem Sreenivas, I created a complete Snowflake folder. Here, I am creating one folder called keys. In this keys folder, I am placing my AWS key pair file. You can place anywhere in your uh, computer team. I am storing in this location. Don't think you also store in same location. You can store in any location you want. So once this one is completed, then 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 here we have create a security group or select existing security group. Okay. I have created one security group called Sreenivas Akkem underscore Sreenivasa security group. If you do not have security group, you can select to create a security group, create a security group, enable 22 port. Okay. Later I'll show how to enable. Then hard disk space, I am giving 30 GB. Then remaining options are optional. Here, one important one, number of EC2 missions. Right now, I want only one. Then click on launch instance. So it is going to create a EC2 instance. Go to instances, refresh. Then here EC2 instance is creating. Here you can see status check. Instance state is pending. Status check, it is going to show you 3 by 3 checks success. It means input, output, resources, internally it is going to check whether those are working properly or not while creating EC2 instance. Once everything is success, it will show 3 by 3 checks successfully completed. Then we can confirm EC2 instance created successfully. Let's wait a few more seconds to complete this EC2 instance process. Instead of refreshing main browser, AWS provides a refresh button inside every service. You can refresh, you can see the status. Let's wait a few more seconds. Yeah, now you can see 3 by 3 checks are completed. Now I want to create a connection between putty to my EC2 instance. Okay, open any web browser thing. I already opened Google Chrome. Go to here and search putty download. Putty download. Then click on first link. You can see, scroll this one. You can see putty putty.exe file, putty.exe file and 64-bit. And I said one more, puttygen. You can scroll here only. You are going to see puttygen, this one. If you want to convert one format to other format, you can download this one. Okay. Yeah. Right now I am downloading putty. So this is first link. Click on this exe file. Then I am downloading this one under my C drive, Akkem Sreenivas, complete Snowflake. Here I am downloading this putty software. Okay. Click on open folder. Double click on this putty. Okay. Just close this one. Then here, if you observe, here it is required host name or IP address. How to find host name and IP address of my EC2 machine? Go to EC2 machine, select EC2 dashboard, go to EC2 dashboard, select your EC2 machine. Here you can see public IP address, public DNS. Let's copy public IP address or public DNS. Then enter that public IP address or public DNS and 22 port number. And here give a name to your session. Snowflake hyphen EC2 hyphen demo. Snowflake hyphen EC2 hyphen demo. Click save. Okay. Along with this one, go to here uh, appearance and change font size equal to 14. Click on OK. Then go to colors. Here use system colors and go to SSH and go to authentication. Click on credentials. Here we have to select a private key file location. Click on browse, then select your private key file location. Under C drive, under Akkem Sreenivas, under complete Snowflake, we have keys. Under keys, we have this PPK file. Select this PPK file, click on open. Don't click on open immediately. Go to session and click on save. Whatever changes we did, right, that should affect to our saved session name. Then now click on open. Then click on accept. Then enter username. Default username for Ubuntu operating system is Ubuntu. Ubuntu. Password we attached keypad file. So it is successfully connected. Now you can enter any Linux command. Any Linux command type. Clear writing? Yeah. Yeah. Now let's continue. As part of Master Snowflake, we are continuing AWS for Snowflake. In that, let's continue AWS S3. In this, we are going to discuss what is AWS S3. Okay, what is AWS S3? And then we are going to discuss practical of AWS S3. So we are going to see how to create a bucket, how to create a folder inside a bucket, and how to upload a file inside a bucket and folder, then how to delete a file from folder or bucket, and how to delete folder from bucket. Then finally we are going to see how to delete a bucket. Okay, we are going to see this complete practical part today. So let's say first let's start understanding what is AWS S3. Any idea what is AWS S3? What is S3? Okay, got it. Yeah, AWS S3 full form is Simple Storage Service. One S means simple, another S means storage, another S means service. Simple Storage Service. It stores unlimited storage. AWS S3, AWS S3 is a storage service. S3 is a storage service and it supports unlimited storage. It supports what? Unlimited storage. You can store unlimited data. Unlimited data. So it's a storage service. It supports unlimited storage. There is no limit, and this is highly available and durable and highly scalable. And another one, we use this service. It supports free tier until 5 GB. You can use this S3 as a free tier service. Once that 5 GB is completed, and you can go with pay as you go model type. Pay as you go basis model means, let's say you stored only 1 GB data. You can pay only for 1 GB data. Let's say if you store 10 GB data, then you can pay for 10 GB data. So based on the data storage size, we can pay to AWS cloud. Next one thing, it is highly scalable. So let's say my business is generating just 5 GB data this entire 3 months. And after 3 months, my application become popular. Then lot of people are using this application. So every day it is generating lot of data. So if you store the data into S3, it automatically scales your storage size. You no need to say, this is my minimum size, this is my maximum size. Based on the data storage inside S3, then AWS people will charge. And next one, you can store any size of data based on your storage, it automatically scales. And it is highly available 24 by 7 without any failure. You can access your S3 data. You can access S3 data from anywhere. Next one, it is available 24 by 7. Okay. And next one, uh, it follows a similar style of Hadoop distributed file system style. Means it supports a parallel processing. In AWS, powerful service called S3. S3 can be used to store unlimited data. Based on the size of data you stored in S3, AWS people will calculate billing for your storage. To make S3 available, highly available, we can use concepts called multi-available zone. Next, we can use cross region so that AWS S3 data available 24 by 7 and 365 days. And next point, let's start doing a practical of AWS S3. So first thing in this we are going to see first creating a bucket. So first you need to log in AWS Cloud. You need to log in AWS Cloud and navigate S3 service. In recently visited services, you can find S3. It means I already used this S3 service. That's why I am able to see in recently visited. In your case, you may started this one account AWS account, or you may created AWS account recently. Then you may not see all the services in recently visited. Then go to search bar and type S3 and you can see S3 service. Right click on this S3, open a new tab. Okay. There are many buckets here, and here we have an option called create a bucket. Click on create a bucket. Then here you can type 1 minute. Yeah. So let me click on create a bucket and give a bucket name. Here I'm giving bucket name Akkem Sreenivasa Snowflake, or let's say Akkem Sreenivasa Snowflake. Akkem Sreenivasa Snowflake. I gave a bucket name. Scroll down. Here you can see block all public access. So if you uncheck this option, it will block public access. Then select I acknowledge. Then below you can see create a bucket. Click on create a bucket. And one important note here, bucket name should be unique across AWS accounts. I created a AWS account. You created a AWS account. Someone created AWS account. If I am creating a bucket, no one should use that name. No one should use that name too. Okay, next one. So here I created this bucket name Sreenivasa, Akkem Sreenivasa Snowflake. In this, you can see there are no folders, there are no files. If you want to create a folder, you can click on create a folder. Then You can give a name. Let's say I want to first let me go to your data sets. In this data sets, you can see a Snowflake. In this Snowflake, you can see employee.csv or employees.csv. So in this, I am creating one folder called employees. Employees. Okay, employees. Then click on create a folder. Then you can just click on this folder. You can use upload option. You can click on add file. Then you can select a file. Under C drive, under datasets, you can see Snowflake. In this, you can see file. This is one way of uploading a file into either bucket or in folder inside a bucket. Next one, another approach. Just go to that file location. You can just select a file. You can just drag a file. So this is another way of uploading a file into AWS S3 bucket. Okay. Next one, I want to delete a file. Or let's say I want to create a file folder, let's say XYZ, then create a folder. In this folder, let's say I want to upload another file. File name is, let's say, transactions.csv. Then click on upload. Okay. Next one. Next one. I want to delete a file. I want to delete a file. Select a file which you want to delete. Then click on delete option. Then you can see message saying you need to type this message permanently delete. You can type this message here. Then you can click on delete object. So if it is a file, we can select a file. We can delete a file directly. Okay, next go to folder. Let's say I want to delete a folder. Select a folder. Click on delete. You can see option saying permanently delete. Enter permanently delete. Click on delete object. Next one thing. Next approach. I want to delete. Let's say I want to delete this. Let's say this one. Sreenivas hyphen AWS DE hyphen live hyphen hands-on demo. I want to delete this bucket. So click on bucket, delete. If I try to delete, it is giving message saying this bucket is not empty. Bucket may contain folders, bucket may contain files. Let's go to see the bucket. So click on this bucket. It contains files and folders. Okay. You can select all these files and folders, delete, or you can select a bucket. You have an option of empty. Click on empty, then type permanently delete, then click on empty, click on exit, then go to bucket once again, select a bucket. Now click on delete. Now it will allow you to delete. Select a bucket name, enter bucket name which you want to delete. Click on delete bucket. So tell me team, how to delete a bucket? Tell me any one example. Select a bucket. Click on empty. Then type permanently delete. Then empty. Next one, click on exit. Go to bucket. Once you make that bucket empty, click on delete bucket. Then it will show option to select a bucket name and enter bucket name. Click on delete the bucket. Hope all of you understand AWS S3, how to create a bucket and how to connect a bucket and how to create a folder and how to delete a folder, how to delete a file, how to delete a bucket. Let's say I want to move data from S3 to Snowflake. S3 is different service from AWS, but Snowflake is completely different from AWS. So if you want to access AWS service, you need a permission. Without a permission, you cannot access. So that permissions we can provide using AWS IAM. Next one. So to move data from S3 location to Snowflake table, we need one more service called AWS IAM. Okay. So as part of master Snowflake, we are discussing AWS for Snowflake, right? As part of AWS for Snowflake, let's continue. One important service is AWS IAM for Snowflake team. What is AWS IAM and what are concepts presented in AWS IAM? Then how we can use AWS IAM in our Snowflake. Okay, let me explain diagrammatically so that you'll get a clear understanding. Okay, let's say uh, we have Snowflake. Let's say AWS IAM for Snowflake. Let's understand what we are going to do with AWS IAM for Snowflake team. Yeah, let's say we have Snowflake, S3. Let's say we have S3. S3, we have data. Let's say this is storage service in AWS cloud. Storage service in AWS cloud. Okay, let's take this is my AWS cloud. Okay, so this is my AWS cloud. And here we store the data, AWS S3. In AWS S3, we will create a bucket. We will create a bucket. Inside a bucket, we will create a folder, and inside a folder, we will get files. We will get files. Okay. So this is my storage part. This is my AWS cloud. AWS cloud. AWS cloud. So data may be coming to this bucket in multiple ways. So data coming into this bucket in multiple ways using data ingestion techniques. Data ingestion team going to load data into here in this location. Let's say team, this is my uh, data ingestion applications. Data ingestion applications. Maybe using Python, maybe using Spark, maybe using different AWS services. They may ingest data into S3 location. S3 location. Okay, once data is presented in S3 location, I want to load it into Snowflake team, Snowflake data warehouse. So this is my Snowflake data warehouse. So this is my Snowflake data warehouse. Okay, Snowflake data warehouse. So here we are going to create a database. We are going to create a database. Inside the database, we will create a schema. We will create a schema. Inside a schema, we will create a table. Table. In this table, we want to load. We want to load this data. This data. So this file data, we want to load into this table. We want to load it into this table. This is our requirement. Requirement. Snowflake using Snowflake techniques. We have a external table concept and we have a Snowpipe concept and we have multiple techniques to load this S3 bucket data into Snowflake table. So let me add this point using different Snowflake techniques. Different Snowflake techniques we use we use different Snowflake techniques to load data from AWS S3 to Snowflake table. We use different Snowflake techniques. We use different Snowflake techniques to load data from S3 to Snowflake table. But by default, it is not possible because Snowflake is different service and S3 is different service. And if you want to access any service in your AWS cloud, we need one special service called AWS IAM. Here, by default, AWS will not allow to access any service in AWS cloud. Let's say AWS having 200 plus services. For any service, if you want access, you need AWS IAM. AWS IAMT. Okay. So here, very, very important one is AWS IAM. So we use AWS IAM. AWS IAM. So using AWS IAM, what we are going to do, we are going to create users. We are going to create users. Okay. We are going to create groups. We are going to create groups. We are going to create roles, and we are going to apply policies. We are going to assign policies to users, groups, and roles too. We are going to assign, we are going to assign, we are going to assign policies to, we are going to assign policies to roles and policies to groups, policies to users. Policy means permission. Let's say I want access S3 bucket. I need S3 bucket policy. If you want to read, you need a read policy. If you want to write, you need a write policy. If you want to delete, you need a delete policy. If you want to modify, you need a update policy. So for every purpose, we have different policies. So to access this S3, file, we need a policy. We need a policy. So here we want to access what? S3 file. We want to access S3 file from our Snowflake. Snowflake. Here we are going to write a command. Here we are going to write commands. We are going to write SQL commands. SQL plus Snowflake commands. Snowflake commands to read data from S3 bucket and then load it into Snowflake table. So to access S3 bucket, we need a permission. So AWS IAM can be used to create a role, attach policy to that role. Then we use that role in Snowflake to access S3 bucket. Clear, right? Snowflake having different techniques to connect S3 bucket. S3 bucket. But only one thing, AWS, we create a role, we assign policy to role. Using role, we can connect to S3 bucket and we can access. So AWS IAM plays very important role while integrating Snowflake with S3 bucket. While integrating, group means group of users. I am saying AWS having users, groups, roles, policy. AWS having different features. Whatever required for our Snowflake, we are going to use. We do not require all the features of AWS IAM. Okay. AWS IAM can be used for creating users, creating groups, and creating roles. Assigning policies to roles, assigning policies to groups, assigning policies to users. So AWS IAM can be used for different purposes. But here, what we are doing, we are understanding AWS IAM features. Later, while integrating Snowflake with dbt, we are going to use these concepts. That time, you never get confused. That's what we are understanding, what is there inside AWS IAM. Later, while integrating Snowflake with S3 bucket, we will create a role we are going to use. First of all, what are different concepts available? If I directly explain, you may confuse. That's why here we are discussing what are features available in AWS IAM. Why AWS IAM? Directly, you cannot access any of these 200 services in AWS directly. Through IAM, we can access. Without IAM, we cannot access any service in AWS. So through Snowflake, if you want to access AWS free, you need IAM permission. Permission means policy. You need a IAM permission called policy. Okay? Clear, right? Let me open AWS console so that you'll get a clear understanding. Go to AWS Management Console. So first log in as a root user or your IAM user. I already logged into this AWS cloud. Now here, if you observe, in recently visited, I am able to see IAM service. In your case, you may be created AWS account recently. You may not see IAM service in recently visited. In that case, in search bar, type IAM and open IAM in new tab. Open IAM in new tab. This one is AWS IAM dashboard. AWS IAM dashboard. Left side, left side, you can see users, you can see roles, you can see policies, you can see groups, you can see groups too. We can see groups, we can see users, we can see roles, we can see policies. Let me create a user. I want to create a user. Click on user, click on user. Let's say creating user called uh, Snowflake, Snowflake hyphen, or let's say underscore user one. Then I am giving access to this management console. Then I am using, I am creating a password. Let's set it. I am creating one password. Then click on next button. Then here attach policy. Click on attach policy. And here I want to give S3 full access to this user. I want S3 access to this user. Okay, click on create user. You can return to users list. Click on continue. You can see Snowflake underscore user is created. Go to groups. Here create a group. Then group name is Snowflake underscore group one. Snowflake underscore group one. And in this I am adding these two users. Then next one, I am creating a group. So this group contain how many users? Two users. Next one, there is a concept called role. Here we can create a role. I want to create a role. Create a role. See here, if you observe, I am creating a role. This is my Snowflake. This is my S3. This is my Snowflake. Snowflake. And from Snowflake, If you want to access here, we need role. I am role. I am role. This role we are going to attach S3. S3. So using this role, AWS Snowflake going to connect to S3. See, what are different options we have to choose? Is it AWS service? Is it AWS account? Is it web identity or single sign-on or custom trust policy? Custom trust policy. While working, while working Snowflake, we are going to choose this custom policy. Custom policy. At this time, I am going to show you this one. Okay. While working with the Snowflake integration with S3, we are going to discuss custom trust policy. Okay. Let first select this AWS service and service use case. Let's say my service is, let's say EC2. EC2 mission wants to communicate with S3. Then I'm creating a connection. Then I am attaching policy S3 full permission. So from EC2 mission, I want to connect to S3 location. And then I'm giving role is Snowflake underscore role 1. Then you can see uh, this JSON message it is generated. Okay, let's click on create a role. Click on create a role. So in this role, observe using I am. First, I created a user. I created a user U1, U1, and like this we have multiple users, multiple users. Then next one, I created group, let's say group one. In this group, I have attached user one, let's say user two, let's say user three. Assume I attached three users. Next one, I created a role. I created a role. Role name is role one. Role name is role one. And in this role one. Okay. Next one, we have policies. We have policies. 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 So these policies for 200 plus services. 200 plus services. For every service, we have different policies: read, write, execute, update, delete, etc. For 200 plus services. Assume S3 related, we assigned to user 1, we assigned to group 1, we assigned to role 1. So in this entire practical session, we did this one only. We did this one only. We understand what is IAM, and we created user, we created a group, we created a role. These are default policies. For every service, AWS defined set of policies. Policy means permissions. So we assigned S3 full access to user, S3 full access to group, S3 full access to role. We see how to create user, how to assign policy. We see how to create a group, how to assign a policy. we seen how to create a role, assign a policy. Okay. Right now, as part of AWS IAM for Snowflake, we understand these things. Okay. While integrating Snowflake with Snowflake with AWS S3, we may going to use either user, group, or role. At that time, I am going to show you which tech of AWS, which technique of AWS I am going to use. Okay. Yeah. So in Snowflake team, in Snowflake, in Snow, we have a concept called external table. We have a concept called external table concept. Okay. We have concept called Snowpipe. We have concept called Snowpipe. While implementing while implementing these two concepts, what we are going to do? That's we are going to read data of S3, data of S3. So for that, what we are going to do, using AWS IAM, we are going to create a role. Using AWS IAM, we are going to create a role, and for this role, we are going to attach S3 policy. S3 policy. Let's say role 1. Every role contain unique number called ARN, Amazon resource number. Amazon resource number. So we are going to use this number inside these commands. Inside these commands, we are going to use this ARN so that whenever you execute these commands can communicate through this role to this S3 location so that we never get permission issue. We never get a permission issue. Clear writing? How we are going to interact uh, Snowflake with S3 with AWS IAM role? Yeah. Mm.